Hello everyone, hope you're all doing well. My name is Bhargavi and I'll be taking you through a series of videos where we will try to understand about Tableau and how it helps us to perform data visualization. So you can think of this like a crash course on Tableau, which should familiarize you with the tool to a very fair extent. Now, let's begin with looking at the overall agenda. What is it that we are going to cover as a part of this course? We will be trying to understand what is data visualization. We'll try to define it, understand the principles of data visualization, look at the installation of Tableau Public. Then we will start exploring the tool. We'll try to see what all are present in that tool, the start page, which is also called the welcome screen. We will look at the data source page and different options available to configure the data over there. We will look at what are the data types supported by Tableau. Try to understand the components and terminologies which are used. Understand about something called as the Show Me panel, different modes of connection, and we will be looking at the difference between dimensions and measures. We will also look at creating some basic charts in Tableau, like text tables and highlight tables. We'll understand what are generated fields and why are they required, how do they help us. We will look at some charts which come under comparative analysis to make a simple relative comparison, like bar graphs, circle views, bubble charts, dot plots. We will look at some charts that help us to show the shares or proportions, to perform part-to-whole analysis, like pie charts and stack bars. We will try to differentiate between discrete and continuous data and understand about discrete line charts and continuous line charts. Similarly, area charts. We're not going to stop there. We will also be looking at how to represent geographical data by using geographical maps. We'll look at a variety of maps like symbol maps, field maps, density maps. And we look at some concepts like how to sort the data in a particular sequence. How do we filter the data and remove what is not required? Keep only the necessary information, eliminate something that might not be required. We will also focus on a slightly advanced concept under filtering, which is called context filters. Then we will be looking at how to build a dashboard. So by then you would have learned how to create a variety of charts. However, in Tableau, we can create only one chart per sheet. Dashboard is a place where we put all these graphs together, we assemble them together and create a meaningful structure out of it. So if you think of each individual graph as a building block, then dashboard is a place where we assemble those blocks together and create a meaningful structure out of it. We will also learn about building stories in Tableau. It's more like presenting our work to the client. Finally, we will wind up the course by understanding how to save our work. Whatever we have created, how do we publish it and save it and share it with other people? So this is going to be the agenda of this particular crash course. Without much delay, let's dive into it. As you might have seen, we have quite a lot of topics to cover. However, I'm going to break it down into smaller chapters so that it will be easier for you to even refer back. You can go to that video where you might want to refer back and learn it again. Okay, so I think by breaking it into smaller videos, it will be easier for you people to follow along, complete your work, and also practice and refer back. So let's begin with the very basic question. We are talking about Tableau, but what is Tableau? It is a tool that is used for the purpose of data visualization. Then what is data visualization? Isn't it? We need to know what it is because that is what Tableau does. It is nothing but representing the data in a pictorial format. It is visual representation of the data. And why is it that we need it? Because we are living in an era where information overflow is happening. There's so much data being generated through so many sources. And if we have to look through each and every record and then come up with some inferences, understand the performance of the business, it would be a Herculean task. It's going to be impossible. That is where the data visualization tools come into play. Rather than going through the data, if we can somehow present that data in a graphical format as graphs, plots, charts, maps, views, visualizations, whatever you might want to call them, representing the data in a pictorial format will make it easier for people to understand the data and draw meaningful inferences, take data-driven business decisions. Because we have moved away from the traditional intuition-driven business decisions. That is no longer in place. From intuition-driven decisions, world has moved into data-driven decisions. So whatever decision is taken about the betterment or the performance of a business, it's all going to depend on data now. So presenting the data well, presenting it in a format that is easily understandable to others becomes the core for any business. And that is why there are so many data visualization tools out there in the market. Tableau being in the forefront. Now, why is it that we need visualization? Okay, how does it matter if we represent data as lines or bars or dots or maps? It's easier to absorb the data. Okay, for example, if I use the term water cycle, whether or not you are able to recollect each and every phase in the water cycle, whether or not you remember those terms, the nomenclature, I'm sure all of you have the image of a pond and clouds in the sky, arrow marks going up and rainfall coming down. Isn't it? The moment you hear the term water cycle, definitely you all have that image in your mind. Or for that matter, think of the periodic table that we had learned back in school. Right? Imagine if you had to learn about all the elements and if they were presented to you in a sequence. Imagine by hearting the atomic number and atomic weight of every element, if it was just given to you as just random text. Instead, what we were given was a beautiful, colorful representation of the elements. That also was difficult to learn, okay? But at least it was much better than presenting it in text format, right? At least it looked colorful. We knew the basic segregation of the elements. So that is the power of data visualization. It really makes life easy. So let's get into how we can create visualizations. Before that, I think the concept of why visualizations is easy. We can do a lot of things. We can detect the anomalies in the data. Outliers can be easily identified. Pattern matching can be done. Okay, all these things which will help us understand our data better. Now let's look at one particular graph. Look at this visualization. So the principle or the goal of data visualization is supposed to be to convey the information at a glance, to give you a high-level understanding about what they are trying to convey at a glance without putting much thought into it. So what do you think about this particular chart? It's a very good visualization because without much thought, at a glance, I understand that it's talking about injuries, bumps, bruises, and breaks. It is talking about injuries and not injuries that have occurred to any normal person. It is talking about injuries that players have suffered during a game season. Look at the attire of that person. Look at the posture of that person. So it is talking about the injuries during a game season. And the top left corner of any graph is a very important space, very precious. Because without our own knowledge, when we look at something without our own knowledge, our eyes are drawn towards the top left corner. That's how we've been reading and writing all through our life, right? So this space is important. You can give the most important piece of information here. Now the picture itself is speaking for this picture is speaking for itself, isn't it? one glance, I know it is about injuries, and I can also, when I slightly pay more attention, I know that most of the injuries have occurred on the knee, followed by that is the ankle. And here it is also giving us the ability to do a deep dive wherever required. It's not just giving you a high level picture and leaving us there. Now, if we want further information about any particular data point here, we can get that as well. So this is a static image, but dynamically, when people go to each point, you can give further information about it. Like if you look at head injuries, in total it is 96, well and good. But out of that, 87 injuries are concussion, 7 jaw injuries, 2 other. So wherever required, it is also allowing us to do a deep dive. That should be the goal of data visualization, to present a high level picture at a glance, and at the same time to allow to do a drill down, to go deeper into that data if necessary. And hello friends, welcome back. This is chapter 2, where we will try to get an introduction to Tableau. So in the previous chapter, we had understood about what is data visualization and why is it so important. Tableau is a tool that will help us perform data visualization. It will help you to connect to a variety of data sources, and it will help you to make the most out of your data. It was founded in 2003 by these 3 gentlemen. Now, however, Tableau has been acquired by Salesforce. Okay, it is basically a tool that comes under SSBI, Self-Service Business Intelligence Platform. How do we install this tool? How to install Tableau on our machine and start working with it? We are going to install Tableau Public. Okay, as a part of this training, we will be using Tableau Public. There is Tableau Desktop, which is the professional edition, which you can get from the following link. But in the training environment, it is sufficient if we download Tableau Public, which you can obtain from this link. Or you could simply visit the Tableau website. When you go to tableau.com and look at the products which are offered by Tableau, you will find Tableau Public as one of the items in the list. When you click on the Tableau Public option, it takes you to this page from where we need to click on the Go to Tableau Public blue colored button here. That will take us to the Tableau Public Gallery, also called as Tableau Public Server. And many people, from the Tableau community, they showcase their work on the public gallery by publishing it over here. Here on the top, there's an option called as Create. And when you hover the mouse pointer there is an option to download Tableau Desktop Public Edition, which is the free version that is used in a training environment. Now, having said that it is free, you need not worry that it might have some major limitations which will not allow you to learn Tableau thoroughly. Nothing like that. You can cover almost 90% of the concepts using the Tableau Public Edition. Okay, so when you click on this, it takes you to the page where you can download Tableau Public. Depending on the operating system that you're using, a version compatible with it will be downloaded. Once you have downloaded it, you run the executable file. There will be a small checkbox where you are supposed to accept the terms and conditions and click on the next button and next again, and then click on install. Okay, once you do this, the tool will be installed on your machine. So after you have installed the tool on your machine, you will be able to find it under the list of tools that are already present, or if it's a Windows machine, you can search for it. Tableau will also create a desktop shortcut. If you're working on a Windows machine, on the desktop, it will create a shortcut for the Tableau Public tool. Now I'm going to double click on it and open it. You can see that it is trying to open up. Okay, so that is how you will install Tableau Public. After you have installed Tableau Public, it's still trying to open. Okay. Here. After we have installed Tableau Public, when we open it, we are presented with the home page. Okay, or it is also called as the welcome screen. We will talk about this, but before we talk about this, let's talk about what other products are present in the Tableau product suite. Because it's not just Tableau Desktop or Tableau Public. There are a variety of products available. We'll just have a one-liner introduction into each of these tools and their purpose. So, to begin with, let's talk about Tableau Prep. Tableau Prep is a tool that is used to prepare the data. So you can think of prep as short form for the word prepare. Suppose your data is not very clean, then you can connect to that data from Tableau Prep and perform certain activities which will allow you to clean the data, combine the data from different sources, shape it, and create a ready-made file with perfect data, which then can be sent into Tableau Desktop. I call this the authoring tool, a tool where we create the worksheets, dashboards, and stories. So we author things here, we create things here. Okay, suppose you have data that is in a very structured format and you need not clean it. Then you need not use Tableau Prep Builder. It is not mandatory to use Tableau Prep Builder. It comes into picture only when data needs some sort of cleaning to be done upon it. So Prep Builder is used only when it is necessary to clean the data. Otherwise, desktop is sufficient. You can directly connect to the data from desktop and create the graphs. Now, after creating the graphs, what next? Why are we creating these graphs? So that we can share it with our end users, right? We can share it with our stakeholders. That is where Tableau server comes into picture. We call this the sharing and collaborating platform, where we can upload our work and people can see what we have placed on the server. It is very, very secure. We can give role-based security, data level security. Now, server is basically a physical machine, right? A very high-end machine with good configuration, which is kept in the server room. And it is taken care of. Like you purchase a high-end machine, you install it in the server room, then you purchase the license for Tableau server software, install it in that tool on that machine, and it starts acting as Tableau server. This is all wonderful, but it is very expensive. However, it is very, very secure. To have the server on premise, it's definitely very secure. But medium and small scale organizations might want a slightly less expensive solution for their sharing and collaborating requirements. That is where Tableau Online or Tableau Cloud comes into picture. This is also nothing but Tableau server itself. However, it is Tableau server that is hosted in the cloud. So we need not go through the hassle of purchasing a high-end machine, then having a server room, keeping this machine, making space for it in the server room. All this is not necessary. We will simply purchase some space on the Tableau cloud. Okay, you would be purchasing some space on the Tableau cloud and you can upload your work there. It is as good as Tableau server. The only thing is, rather than having it on premise, you're taking the hosted version, which is maintained by Tableau people themselves. And these Tableau clouds, which are basically nothing but servers, are installed geographically across different locations. There is a server in Australia. There is a server in Japan. There are multiple servers in the United States, across the world. It's simple. When you click a picture on your mobile phone, photos are automatically backed up to Google Cloud or to Apple Cloud. Similarly, when you create graphs on Tableau Desktop, you can publish them on the Tableau Cloud, which is nothing but the Tableau online platform. And when you create an account for yourself on the Tableau Cloud platform, you will get 100 GB space and you can share your work with other people through that space. Then there is something called as Tableau Reader. It is a tool that is used to open the workbooks which are built in Tableau Desktop in read-only mode. You can open them and you can interact with them. However, you cannot create anything new. You cannot modify or edit the report. So Tableau Reader is a tool that will help us open the workbooks in an interactive mode Which workbooks? The ones that are built on Tableau desktop. It is a free tool. This is a free tool. Then there is Tableau Public, which is a free version of Tableau desktop. See, the license for Tableau desktop is quite expensive. In a training environment, we need not purchase such an expensive tool. So what Tableau people have done is they've given us something called as Tableau Public, which is similar to desktop, but it is a free version of desktop. And we can connect to different data sources from public, and we can create visualizations and dashboards. So public and reader are free, whereas the rest of the tools, Tableau Desktop, Tableau Prep Builder, Tableau Server, Tableau Online, these are all paid tools. So this was a simple one-liner introduction to the various products which are offered by Tableau. And we will be learning how to work with Tableau Public in this program. Okay, so as I was telling you all, the moment you open Tableau, you're presented with the start page, which helps us to connect to our data, which helps us to open the most recently used workbooks in the open section, helps us to discover and explore content produced by the Tableau community, which is the purpose of the Discover section. Okay, so the moment we open Tableau, we are presented with the welcome screen, the home page, where we can notice that it is divided into 3 parts: connect, open, and discover. Now, for a moment, let me switch to an Excel here. What happens when you open an Excel? You're immediately presented with a worksheet, isn't it? We are presented with the worksheet. And we can do whatever activities we might want to do over here. Type in some data. This is sheet number 1. Let's say my work on sheet 1 is done and I would like to proceed to the second sheet. I'll have to click on this icon, which will open a new sheet. Bottom left corner, new sheet, plus sign. So now I'm on sheet number 2, and then I can do whatever activities I might want to do here. Proceed to the next sheet. So it's basically a collection of a lot of worksheets. And when we ultimately decide to save it, it is saved as an Excel workbook. An Excel workbook containing multiple sheets. Now, why are we talking about Excel all of a sudden? Because Tableau also follows the same paradigm. Tableau is also a collection of worksheets, and all of them put together is called as a Tableau workbook. Okay, it's called as a Tableau workbook. However, in Tableau, the moment we open it, we are not presented with the worksheet. Even if we come to the worksheet, there's nothing that we can do. Not until and unless we connect to data. So that is the first thing to do. From the home page, the most important section on the home page is the connect section. It will help us to connect to a variety of data sources. Open section initially would be blank, but when you start creating different types of charts, the open section will show you the workbook as a small thumbnail, and just by clicking on it, you can open it. So it's something that will help you open your workbooks with just one click. Discover is, of course, the place from where you can visit the Tableau public gallery, you can get sample data sources, etc. I repeat, the most important section on the home page is the connect section, which will help us to get connected to a variety of data sources. How do we connect to a data source? For instance, if I have to connect to an Excel, I will have to choose the file type, which is Microsoft Excel. Then navigate to that location on my machine where the data source is present, select the data source, and click on the open button. Okay, so what are the steps? We have to choose Microsoft Excel because I'm trying to connect to an Excel file. Navigate to the location where the file is present, select it, and click on the open button. So let me quickly open it. Once we do this, okay, after we have selected the data source and click on open, Tableau takes us to the next page, which is called as the data source page. So from the start page, after getting connected to the data, we proceed to the data source page. Okay, let me just cancel it out and try it again. Okay, so here we are on the data source page. So what does the data source page show? It shows us the name of the data source to which we are connected, the type of the data source, and list of worksheets or list of tables or list of schemas present in that connection. Before we go any further here, one small point. See, any project that you might be working upon, there are 4 things that we need to understand or take care of. We need to understand the requirement, right? Until and unless you have a fair understanding of the requirement that you're working with, there is no point proceeding further. So understanding the requirement is definitely very important for any project. And equally important is to understand the data, which many people don't give as much importance, but it's very, very important to understand the data. The more familiar, the more comfortable you are with the data, the easier it would be for you to come up with an optimum solution, optimum answer to the given requirement. Then we need to understand our audience. For whom are we creating the report? How is it going to help them? What kind of questions is it going to answer? Because we may not create the same report for people at different levels in the organization. Let's say you're creating a report for the CEO of the company. Then you would definitely want to present a high-level overview of the overall performance of the company, right? Across branches, across states, across countries. At the same time, give them the option to further investigate. Maybe they would like to know about the performance of a particular state, in that state, a particular branch, in that branch, a particular product. So they get complete control on the entire data through a summary report with the ability to deep dive. Imagine you're creating a report for the same organization, but for the workforce, let's say for a sales representative. Would you give the same report that you have shared with the CEO? Definitely not. That person may not be interested also, right? What would that person's focus be? Let's say a sales representative of an organization would want a report which will help him or her understand how is that person's performance against the given targets or goals. Will I be able to reach the target? How is my performance with respect to my past performance? Am I doing better today compared to what I did yesterday? How is my performance compared to my peers? Right? These are the kind of questions I would be interested in if I am a sales representative. And if I am presented a report about my performance, me against my target, me against myself in the past, me against my competitors. So depending on the audience, you will have to tweak the reports accordingly. Finally, we need to understand which chart to create when, because there are hundreds of charts that we can create in Tableau. And after going through the entire training, if you have confusion on when am I supposed to create this chart, or given a requirement, if you are confused on which chart to create, then there is no point going through the training. So generally in our training, what we do is before we start any chart, we first discuss about when to create that chart, for which type of requirements you are supposed to create that kind of a chart. Only after understanding the when aspect, we proceed to the how aspect, how to create the chart. Because how to create is pretty simple. It is a series of steps that we will have to follow, which we can even memorize and just do it by heart and do it. But to logically reason out and understand when to create that chart, which type of chart to create for a given requirement, that is where it becomes a little difficult, and we focus on that a lot. Okay, so these are 4 things that we need to understand. Now, why am I talking about this? Because we are connected to our data. We are connected to our data, which is sample superstore. And we need to understand this. Only when you understand this, proceeding further will make sense. So here I'm going to take a moment and show you the data that we have in sample superstore. This is a very simple data source. It has information about transactions of a retail business. Okay, superstore is a retail business where different types of products are being sold. Different types of products are being sold. Now, similar products are brought together and placed under a subcategory. For instance, let's look at tables, okay? So there is some sling rectangular table here. There's a conference table here, so on and so forth. So all tables, they come under a subcategory named as tables. All storage units, which are mostly used in offices like drawers, shelves, carts, they all belong to a subcategory called as storage. So similar products are put together or grouped together and placed under various subcategories. Okay, under subcategory. Now, similar subcategories come together and form a category. This is the next level. Similar subcategories like bookcases, chairs, tables, and furnishings come together and form a category called furniture. Things related to technology like phones, copier machines, Xerox machines, they all go under technology. Office supplies, things that we use in offices, labels, adhesive labels, binders, storage units, okay, art, these kind of things go under office supplies. So I hope you're all able to understand the hierarchy in here. What is the hierarchy? We have data for three categories: furniture, office supplies, and technology. Under each category, there are multiple subcategories, and under each subcategory, there are different products. That's the hierarchy. If you think of category as the parent, subcategory is the child. If subcategory is the parent, you can say that product is the child member. Okay. So products are categorized into three categories. When people come to Superstore, now they are selling different products, right? So people would come and purchase the products. Customer information is recorded, like the name of the customer. Every customer is given an ID called as customer ID. Like products are categorized into three types, similarly, customers also are segmented into three types. We have consumers who are probably purchasing the items for their use. They'll keep it in their home. We have corporate customers, big corporate giants, who will generally purchase items in bulk. And we have home office customers, maybe for a small office setup somewhere in the neighborhood. So customers are categorized or segmented or divided into three types: consumers, corporate customers, and home office segment customers. Information like the address of the customer, which country, under that country, which region, under that region, which state, which city, what is the postal code, that is recorded. So there's another hierarchy here, right? There's another hierarchy. Country, which contains regions. Region, which contains states. State, which is divided into cities. City, which is divided into postal code areas. So there is another hierarchy. Now, when people come and they purchase products, they place an order, right? When they are purchasing products, it means that they are placing an order. An order ID is generated to recognize every order in a unique way. Under an order, a person can purchase multiple items. If you take Brosina here, she's purchased a lot of items under one order, many products. Or a person could purchase only one item. Like Darren Van Huff, under this order, has purchased only one item. Right? Let's say you went to a mall. Okay, you go to a mall and you enter the mall, you do your shopping and come out. It's possible that we might purchase only one item, right? Nobody is going to stop us and say, no, you have come to this place, so you have to purchase many things. No, nothing like that. So depending on their requirement, people could have purchased only one item, or they could have purchased multiple items. Think of order ID like the bill number or the check number or the receipt that you receive. You go to a mall, you put all the things that you want to purchase in a trolley, and then at the checkout, we pay for them. Are we going to get a separate bill for each and every product that we purchase? No, right? We get one bill, under which all the items that we have purchased would be listed out. Whatever we have purchased would be listed out, and then we pay for them. The total amount is paid for. So that is order item. People could purchase only one item, or they could have purchased multiple items in an order. Row ID is a field that recognizes each and every record in a unique way. First record, second record, third row, fourth row. And when a customer places an order, the date when the order is placed is recorded, which is order date, and date when the order is shipped out or sent out to the customer is also recorded. There are 4 modes of shipments available. People can choose first class shipment, or same day shipment, or second class shipment, or standard class shipment. Okay, so this is all categorical data, meaning who is the customer, what did they purchase, which product, when did they purchase, how was it shipped out to them, what is the order ID, what is the address. Now, what about the quantitative data? The numericals. What is the selling price? How many products were ordered? How many chairs? How many bookcases? How many tables? Was there any discount offered? And what is the profit that the business made by performing that transaction? So selling price can be a decimal number, as you can see. Quantity is the number of products. It's going to be an integer. Decimals can't be allowed here. We can't purchase 3.5 tables, 2.5 chairs, right? So this is going to be an integer number. Discounts are stored in decimal format. 0 means no discount. 0 means 0% discount was offered. 0.45 means 45% discount was offered. 0.2 means 20% discount was offered. Okay, it is stored as decimals. Then we have profit. Now, profit is also stored as decimals. We can have decimals, and it could be negative also. It's not necessary that every transaction should always give a profit. It might also give us a loss. So negative values are quite possible in the profit column. So this is about data present in one sheet called as orders from Superstore. Like that, we have 2 more sheets. Returns, which contains information about the orders which are returned by the customers. Okay, that is also quite possible. After people have placed an order, let's say upon receiving the order, they don't like it and they are going to return it. So returns has information about the orders which are returned by the customers. Then we have the people sheet, which has names of the regional sales managers of Superstore. So this is the data that we will be working with throughout the training. We will be working with the orders sheet from Superstore, the returns sheet, and the people sheet. So whenever you people get time, do spend little amount of time understanding this data, because the more familiar you get with this data, the more easy it would become for you to understand the charts when we start creating them in the subsequent modules. Okay, friends, I hope this information was useful. So we talked about how to install Tableau. You can go to the Tableau website and install it. After installing Tableau, when you open it, you're presented with the start page, which is used to connect to data. Okay, so we shall stop here, and I will see you in the next video where we will talk about data source page. We will explore the various options that are there on the data source page. Thank you all so much. See you in the next video. Hello everyone, welcome back. This is chapter 3 of data visualization using Tableau. In the previous 2 chapters, we had looked at certain things like how do we install Tableau Public, and after installing the tool, when we open it, we are presented with the start page. And on the start page, we understood that connect section is the most important section because it helps us to connect to a variety of data sources. And after connecting to the data source on the connect section, we are taken to the data source page. And here now the agenda for This chapter is to understand about the data source page, explore it, understand what are the data types in Tableau, how to change the data type, how to rename a field, how to hide the fields which are not necessary and unhide them when required, and how to give alias names. After we get connected to the data, we are automatically taken to the data source page. Okay, where we basically configure the data connection by dragging and dropping the tables. So let's look at that. Here I'm on Tableau and I'm going to connect to Sample Superstore, the data source which we had explored or understood in the previous session. So on the data source page, Tableau is showing me the name of the connection, type, and the fact that there are 3 sheets in this connection. Now to use data coming from any of these sheets, I'll have to simply drag and drop. It's that simple. Most of the things in Tableau are drag and drop. So I just dragged and dropped orders in this area. Immediately down here, it is giving me a preview of the data. So once we drag and drop the tables, we get a preview of the data here, and this area is referred to as the data grid. Now, it's telling me that there are 21 fields in this table and 9,994 rows. Apart from just giving me a preview of the data, here what you will notice is Tableau is also showing us the name of the field, the table to which these fields belong, and it's giving a visual icon, a queue. So what do these icons represent? They indicate or they represent the data type of the fields. If you see a hash symbol, it indicates numerical data. And under numerical, Tableau clearly distinguishes between whole numbers and decimals. So here it is a whole number because it is row ID. Row number 1, row number 2, row number 3. So definitely it's going to be a whole number. Similarly, if you look at quantity, which indicates the number of products, for instance, 2 here means 2 big bookcases were sold. 3 chairs were sold. 5 tables were sold. So this is also going to be of whole number data type. Okay, this is also a whole number. Sales, discount, and profit, which have decimals, you can notice the data type is of type decimal. Numerical itself, but under numerical decimal. And that is the default data type which Tableau has assigned to this field. Number decimal is the default data type which Tableau has assigned to the field. That is why default is ticked. The next data type is ABC. I'm sure most of you might have guessed by now what it indicates. It indicates text data, string data. String meaning alphabetical data, not just alphabetical. Whether the data is alphabetical or alphanumerical, for instance, order ID. So alphabetical and alphanumerical data is treated as string data. Then if you see a calendar icon, it means the data type is date. Tableau has recognized that that particular field holds dates. So you can see the calendar icon and the data type is date, which is the default data type which Tableau has set up for this field. Now, what if you might want to change the data type? Generally, Tableau does a good job. It will be able to identify the data types accurately. But if at all you feel that the data type is incorrect and needs to be changed, how do we change the data type? It's very simple. You will click on the data type icon and then choose the appropriate data type from there. Let me select date and time for this field. Date and time. So Tableau is going to assign date and time. Actually, there is no time here. So it is giving default time, which is 12 a.m. And what I actually want to show you is this icon here. Okay, calendar with a clock is an indication of date and time, which I modified for this field. Okay, now I'll switch it back to date. I'm going to switch it back to date. So that is how you change the data type. Now, what else? We have one more data type, which is Boolean, which we don't have in Superstore as of now. But later on, when we do calculations, I will show you one field which will give output as Boolean. And the icon for a Boolean data type will be like this, T/F. Boolean meaning the field which contains only true or false values, yes or no, 0 and 1. That kind of data is considered to be Boolean data, and that would be the visual cue. Next, you will also notice a globe in some places. In the place of data type, you will also notice sometimes there is a globe. So globe is not a separate data type by itself. Okay, if you look at the information, this is United States. It is alphabetical. City, alphabetical. This is alphabetical. And this is a number. And clearly it's a whole number. So number, whole. This is all text only. This is all string data type. And this is numerical whole number. However, there is something special about them. What is special about them? These fields are holding names of geographic locations. They are holding names, though it is a simple string. It is not just any ordinary string. It is holding the name of a country, which is a geographic field. So when you have geographical data in your data source, Tableau would automatically recognize it and it will assign an appropriate geographic role. For country, you can see the role is country. Okay, in the case of state, which is also string, but there's a geographic role for it, which is state. And if we look at postal code, there is a geographic role for it, which is postcode or zip code, which means there is something special about it. The special thing is it is geographical data. Tableau automatically distinguishes geographic and non-geographic, and it indicates geographic data with the globe icon. Okay. Now what next? We can also go ahead and rename a field. Let's say I want to rename this field. Instead of shipment mode, I would like to rename it and call it shipment used or shipment preferred. So upon selecting the field, you see the small drop-down icon. When we click there, there is an option to rename. When I click on the rename option, this becomes editable. Or you could simply double click on that name, even then it becomes editable. And we can change the name. Let's say shipment mode preferred. Okay, so the name of this column by default was ship mode, but I changed it to shipment mode preferred. So it is possible to even rename a field. If you think some names are very technical, it's difficult to understand, and by renaming like this, it will make more sense. You can definitely go ahead and rename it. Now, let's say there are some fields which I don't need. I don't have to, I'll not be using them in my analysis, and therefore I don't need to see them. I don't want them. I just want to get rid of them. So how can we remove a field? We can't delete it, but what we can do is we can go to that field and we can click on the drop-down icon and choose to hide it. A field that is not necessary can be hidden. Let's say I'm going to hide customer ID now. Okay, I've hidden customer ID. Now, how do I bring it back? Let's say a new requirement has come where the customer or the client needs us to use the customer ID in a chart. I need it. So how can I bring it back? Okay, if we go ahead and hide a field, how do we bring it back? To bring it back, we must go to the settings option and then select this option called as show hidden fields. When we select the show hidden fields option, it will bring back the hidden fields. At least we know which all fields were hidden. However, they are disabled or they are deactive. They are not active. You can see this is active field and this is an inactive field. So now we have to go to that field and then unhide it. Okay, go to the field, click on the drop-down icon and unhide it. So hiding is simple, but for unhiding, you have to go to the settings option, select the option to show the hidden fields, and then you have to unhide them. We can even give an alternate name, an alias to the values in the field. So rather than calling it as second class shipment, maybe I would like to call it as economy. Okay, and instead of calling it as standard class, let's say I want to rename it and call it as standard mode of shipment. For first class, let's say I would like to use something called as premium shipment. For same day, I would like to call it as urgent shipment. So how can we change or give an alternate name and alias to the values present in the field. We go to the field itself, click on the drop-down icon, and you will see an option called as aliases. Once I select aliases option, Tableau gives me a pop-up window. So the name of the members in the ship mode field, name of the members, what are the names? First class is one member, same day is another member, second class is a member, and standard class is a member. Now I'd like to use a different value for them, an alias. So I'm going to click there, and instead of first class, I'll change it to premium shipment. Instead of same day, I'll call it urgent shipment. Let's say for second class, we'll call it economy. And standard class, let's call it standard mode of shipment. Okay, so I've given an alias name, an alternate name to the values in that field. You can see the aliases have appeared. Standard mode of shipment, economy, etc. Let me just show you all the four. So when I use ship mode or the shipment mode preferred, you see all the four are different: economy, premium, standard mode shipment, and urgent shipment, based on the changes that we made in the data source page. Now, how do we bring back the original names? I gave an alias name, fine, but how do I go back and bring back the original names? So again, we go to the settings icon and we uncheck show aliases. Right now it is showing the aliases. If we deselect the show aliases option, it is going to show us the original names from the data source. And one very important point to remember is whatever changes we make to our data here in the Tableau workbook, whether we drop a field by hiding it, or we rename a field, or we give alias names, or we change the data type, whatever it is that we might do, it is local to only this workbook where we are making the changes. These changes will not get written back. They will not be reflected back in the underlying data source. Okay, they are local and relevant only here. Now, after making the necessary changes to your data, after you have configured the data properly, you can now proceed to the worksheet. And on the worksheet, we'll go ahead and learn how to create a variety of charts. Before that, we'll explore it and then do it. That would be in the next module. So in this module, we have understood how to configure the connection. We understood about the data types and where to check for the data type, right? So we have text values, that will be alphabetic and alphanumerical, date values, then we have date and time, we have Boolean, okay, and numerical. Under that there is a clear distinguishing that happens between the whole numbers and the decimal numbers. And of course, geographic values, okay. Tableau recognizes geographic values and assigns a globe icon. Then we spoke about how to change the data type. Let's say, for instance, over here, date is interpreted as string. So we can simply click on that icon and choose the appropriate data type, and the data type will get modified. We can also go ahead and hide a field that is not required. After you have hidden it and it disappears, to bring it back, we click on the settings button and select the show hidden fields option, which will show us all the hidden fields. Now we have to go to each hidden field and unhide it. Okay. Next, we can also unhide a field from the data pane in the worksheet. After you have reached the worksheet and you start creating a chart, if it's necessary to unhide a field, we can go ahead and unhide and we can make it active. So the key takeaways from this module are that we explored the data source page, we understood about the data types, we looked at how to change the data type, how to rename a field, hiding and unhiding of fields, and giving aliases. Okay, I hope it was informative. Thank you all so much, and I will see you in the next video where we will explore the worksheet. Thank you. Hello everyone, welcome back. Hope you're all doing well. In the previous video on data visualization using Tableau, we had explored the data source page, right? We understood various sections on the data source page. We had an idea about the data types in Tableau, how to change the data type, how to rename a field, how to hide and unhide fields, and how to give an alias. So in this particular video, we will be exploring the Tableau user interface at the worksheet level. Okay, we saw start page, we saw data source page. And once we configure the connection, we move to the sheet. Here we're going to look at the different components that are present at worksheet level. So we will also differentiate between dimensions and measures. We'll try to understand the difference between discrete and continuous data. We'll understand the purpose of something called as rows shelf and columns shelf. And we will look at the show me panel. So that's the agenda for this video. Let's first understand the components and the terminologies that we will be using. Okay, when you go to the worksheet, this is what the screen looks like. This area here is referred to the canvas or the view pane. We have different shelves over here. What is you see as columns is columns shelf. There's a rows shelf, pages shelf, and filters shelf. Then we have something called as the marks, which is called as marks card, which in turn comprises of multiple shelves like color, size, text, detail, tooltip. And there's a blank space which gets filled with an appropriate shelf depending on the type of the chart that you create. At the top, we will have the very familiar menu bar, followed by that is the toolbar. The purpose of a toolbar in any application is to bring about the most frequently accessed features as a small icon like that. That is what we see here. Simple small icons for various purposes. Okay, and here what you have on the right side is called as the show me panel. We will be exploring this in detail. So let's get into the worksheet. We had configured the connection. To that extent, we've seen in the previous chapter. Now let's proceed to the worksheet. Now, how do we go to the worksheet? After you have configured the connection, you can notice the sheet 1 option, okay, on the bottom left corner of the screen. So once I click on the sheet 1 option, Tableau is going to take me there. We have the menu bar, like the file menu, data menu, worksheet menu, so on and so forth. And we have the toolbar. For instance, this floppy disk icon to save our work. We can use the back arrow to undo. These icons are used for sorting the data in ascending and descending orders, etc., etc. So menu bar and toolbar are common. They are present in almost all the tools. But then the interface changes. It looks a little different. And this might be something new to many of you. So what we have here as data is referred to as the data pane. Okay. It's called as the data pane. P-A-N-E, data pane. And what we see in the data pane is the list of data sources to which we are connected in the workbook. And in one workbook of Tableau, we can have multiple data sources. Okay, here right now I have only one data source. And from that source, sample superstore, I've used the orders table. But we can have multiple connections in a workbook. In the data pane, we can see the name of the data source and then the fields from that data source appear, which are segregated into dimensions and measures. You can notice that there is a very subtle gray colored line over here, this line. Okay, the fields above the line are dimensions and the ones below the line are measures. So let me just do this. Suppose I drag segment. Look at that. So there is a very subtle line. Above that, what you see are dimensions. Below that are measures. Okay. So what are these things? What are dimensions and what are measures? Let's discuss that first. So I'm going to talk about measures. Measures are those values in Tableau which are always presented in an aggregated form. Measures will have a default aggregation property associated with them. It could be summation. If you want, you can change it to average, median, count, distinct count, minimum, maximum, percentile, standard deviation, variance. We have so many options. Right now it is sum. They have the default property is sum, which means when I use profit and try to create any sort of a chart, right now it's a simple text information. Okay, I'm displaying profit as text. It is not going to show me each and every value present in the profit field. Tableau is not going to show us each and every number present in the profit column. It's not showing us 49.91, 219.58, 6.87. No. What did it do? It's showing us the sum of profit, meaning it summed up the entire data present in the profit column. All the data that we have from the 9,994 rows. The entire data in the profit column is summed up and the overall profit got displayed. So this here is the overall profit made by the business. Why is it doing so? Why is it not showing us each and every value? That is because measures in Tableau are always aggregated by a default aggregation property, which if you want at graph level, you can change. Let's say I'm interested in looking at the average. So I'll go to that pill, go to this measure option and change it. If I choose average, it will show me the average of profit. I'll switch back to sum. So what kind of data would you like to aggregate? What type of data would be used if you have to perform any sort of mathematical operations on it? Maybe addition, subtraction, multiplication, division, or or aggregations like average, okay, median, standard deviation, variance. We do such mathematical operations on numerical data, right? We can't do it with string data or date fields or text fields, or date and time fields or Boolean values. We do it on numbers. So let's say measures are numbers. Is it that simple? Let's see. It's not as simple as all numbers are measures. No, because there is an exception here. If you observe row ID, it is also numerical. However, Tableau did not place it in the measures pane. It is treating it as a dimension. Now, why is that so? Because these are identification numbers which are used to explicitly identify each and every record. Let us assume for a moment that Tableau made a mistake. Okay, it made a mistake by placing the number in the dimensions pane, and I would like to fix it. How to convert a dimension into a measure? It's pretty simple. Drag it and drop it. Drag it from the dimensions pane and leave it in the measures pane. It becomes a measure. Now, if it becomes a measure, what will happen to it? If it becomes a measure, by default, it will have an aggregation property. So if I use this field on the canvas, on any type of chart, Tableau is going to show me the summation of the data present in the row ID column. And it has given me this big number. So what did it do here essentially? It went to the row ID column and summed up the information in the row ID column. 1 plus 2, second row, plus 3, third row, plus 4, 5, 6, 7, so on up to 9,994, which is absolutely meaningless, isn't it? How will this number help us? Summing up the data in the row ID column is not going to help us in any way. It's not meaningful. So here, this is a field on which all the aggregations will not hold good. I agree that count might hold good, right? We could get the count. Count is definitely meaningful. We understand that there are 9,994 rows. However, most of the time, we would want it just as the field itself. We might be interested in the values and not in aggregating it. So I'm going to convert it back to a dimension. We'll just drag and drop it in the dimensions pane. It becomes a dimension. So the bottom line is those fields on which when you perform any sort of mathematical operations will always give you a meaningful result are measures. Okay. So all numbers on which we can do mathematical operations and get a meaningful output are measures, except all numbers except identification numbers. Okay, for example, let's say employee ID. Let's say there is an employee in an organization, ID of the employee is 500. And that person's colleague's ID is 501. If I'm going to sum up these two and say there are more than 1,000 employees in my organization, that would be absolutely wrong. We have only 2 employees whose employee ID happens to be 500 and another person's 501. That doesn't mean that we will sum up this and tell we have 1,000 employees, right? So therefore, identification numbers are not considered as measures. All numbers on which when you do mathematical operation gives you meaningful result are measures. So the exception for this is identification numbers. So I hope you all understood what are measures. Measures are those values which when aggregated will give you a meaningful output, or on which when you do any sort of mathematical operations, they will give you a meaningful output always. Unlike only in the case of count with row ID. Okay. So if we have understood what is a measure, now defining a dimension becomes easy. See, a field coming from a data source is either a measure or a dimension. There is no third place to go to. There are only 2 options. Something has to either go into the dimensions pane, otherwise it has to go into the measures pane. So if something is not a measure, what is the only other place left out? Dimension. So if I'm saying that all numbers are measures, then what about dimensions? All non-numeric values, right? Which would be what? String data, date fields, date and time data type fields, Boolean data type fields, right? All these non-numerical values are going to be put under dimensions, and along with this, including identification numbers, which we had excluded in the previous case, in the previous scenario. So, including identification numbers, all numbers, all non-numerical values, including identification numbers, will go into the dimensions pane, as you can see here. I hope the difference between dimensions and measures is clear. Now, when we use a dimension in a graph, what will happen? When we use a measure, we saw that it gets aggregated. But when we use a dimension, what happens? The unique values from that field are fetched and they are displayed. Okay, so if you look at the data present in the category dimension, we have furniture, multiple occurrences of furniture, multiple occurrences of office supplies, and technology, because those are the 3 categories to which all the products ultimately belong. But Tableau is not showing us each and every occurrence of furniture or each and every occurrence of office supplies here. It's picking up the unique value from the category dimension. These are the members in that field, right? Furniture is a member. Office supplies is a member. Technology is a member. So unique members from the field are fetched and displayed. And look at how it has displayed them as rows. Furniture is a row. Office supplies is a row. and technology is a row. Why did it display them as rows? Why not as columns? Simple, because I have taken that field into the rows shelf. So here we are trying to understand another point. When you take any field to the rows shelf, you're telling Tableau to show the information from that field as rows. Central is a row, east is a row, south is a row. So they're getting aligned one below the other, forming a row. If I take this into the columns shelf, then members from that field are going to appear as columns. Central is a column now. East is a column. South is a column. And west is a column. Because it is on the columns shelf. It is that simple. And observe one more thing. The color of this field. It is referred to as a pill. Okay, this is referred to as a pill. Simply because it is in the shape of a capsule. That's it. Now the color of this pill is blue. It is a blue pill. Blue pill indicates discrete data. And by default, all dimensions are discrete. Discrete meaning what? Discrete is basically a field with a distinct set of values in it, countable set of values, a distinct set of numbers or members in it. Okay. For example, region. Central is one unique member. East is one unique member. South is a unique member. And West is a unique, distinct member present in that field. So distinct means something with a distinct set of values. How many ever values it could be? If I take order ID, there are more than 5,000 order IDs. Okay, there are more than 5,000 members, but all of them will be listed out. Each and every value is listed out. Look at the bottom left corner, 5,009 marks. Means there are 5,009 orders here. 1, 2, 3, like that. So it doesn't matter how many, maybe a million or a billion. It doesn't matter, but it has unique, distinct values which can be listed out like this. And when you have a blue pill indicating discrete data, indicating distinct set of values, here on the header, this is called as a header. Okay, this is called as a header. If I right click, you will notice. What we are getting are called labels. Central, which is a member in the region field, East, which is a member present in that field, they are referred to as field labels. Okay, so when you have a blue pill, in the graph, we will get field labels. Field labels means what? Members. The dimension members will appear as labels. Okay. Now let's talk about dimension. Measure. Okay, let's take profit. I'm going to take profit into the rows shelf. Observe the color of the pill. It is green in color. So green pill represents continuous data. And by default, all measures are continuous. What does it mean when I say continuous? Continuous field meaning something with a range of values in it. Okay, it doesn't have distinct values, but it has a range of values. For example, if you take profit, if you observe the data in that field, there is going to be some minimum value. For profit, there will be some minimum profit. So here there is a loss of 6,599.98. There's going to be some maximum value, a profit of 8,399.98. And you pick up any number in that range. From min to max, any number that you take is going to be valid. Okay, so continuous meaning something with a range of values in it. It will have a range of values in it. And how does the information from a green pill, a continuous field, get reflected in the graph? It forms an axis. an axis with a range of values. So when we have a green pill, in the graph, we will get an axis with a range of values in it. Okay, it will give an axis with a range of values in it. I hope you'll understood the difference between blue pill and green pill. It's a very, very important concept. Difference between dimensions and measures, difference between green pill and blue pill, meaning continuous and discrete data. Now let's come back to the purpose of columns and rows. So where did I take the profit pill? I took it into the rows shelf. Now when you take a field to the rows shelf, what are you telling Tableau to do? You're asking Tableau to show the data from that field as rows. But this is a range of values, right? So we will get the range of values cutting across rows, 10K, 20K, 30K, 40K. It is cutting across rows. If I had taken this to the columns shelf, it would form the x-axis cutting across columns, 60K, 80K, 100K, cutting across columns. Let me bring this down here. Okay, profit is on the columns shelf. So it's going to have a range of values which will cut across columns like this. Therefore, it must form the x-axis. Okay, that is the purpose of rows and columns. Now, how do we know which field should go to the rows shelf? Which field should be placed on the columns shelf? Is there a rule for that? There's nothing of that sort. It's your choice. As a person creating the chart, you decide. Okay. See, if I have taken region to rows, I'm asking Tableau to arrange regions as rows. If I've taken profit to columns, I'm asking Tableau to show the data from the profit field cut across columns. And it has automatically given me a horizontal bar chart. If I do it the other way around, this is the swap icon. It will interchange rows and columns. Now, if I do it the other way around, then region can see here. Members, the field labels are appearing as columns, okay? And profit on the rows shelf has formed a y-axis with data cutting across rows. So if you like the representation like this, you leave it like this. If you like the horizontal bar representation, you swap it. It's your choice ultimately. As a person designing it, you have complete control on it. Okay, so that's about data pane, dimensions, measures, green pill, blue pill, discrete, continuous, columns and rows. Next to data pane, we have the analytics pane, which has some analytical capabilities of Tableau listed out. We have the pages shelf, filters shelf, then the marks card. We'll talk about it a little later. Okay. Now let's talk about the Show Me panel. This is called as the crown jewel of Tableau. Okay, and it has 24 graphs arranged as 3 columns and 8 rows. There are 24 graphs. And this is like your best friend, especially if you are new to the concept of data visualization. This is going to come in very handy. Okay, when in doubt, you just open the Show Me panel and check. Suppose I want to create a bullet chart. This is a bullet graph, okay? So how do I know that this is a bullet graph? When you hover the mouse pointer on any chart, this lower section of the Show Me panel gives you the name of the graph and the number of fields required to create that chart. How many dimensions would be necessary or how many measures are required to create that chart? Here, bubble chart, Gantt chart, scatter plot, okay, line chart, so on and so forth. But right now, all of them are deactive, disabled. That is because we didn't select any input. As I start choosing the fields, okay, and I'm going to hold down the control key and select profit also. If you're using MacBook here, then you'll hold down the command key for multiple selection. So I've selected category and profit. For this combination of input, Tableau has activated a lot of graphs here. It's saying I can create this, which is a text table. Or I could go ahead and create a heat map. I could create a highlight table, a pie chart, horizontal bar graph, stack bar graph, tree map, circle view, box plot, or a pack bar. So many options. And I hope you all have noticed how easy it is to switch between the views. Let's say you created pie chart for some requirement, and then your client has a change of mind and asks you to create bar graph. With one click, you can convert it. Hassle free. Okay, so it's that simple. Now, for all the charts which Tableau has activated here, horizontal bars are outlined in red color. This is Tableau's recommendation. It is not a rule to be followed. It is simply a recommendation which you may or may not accept. It's your choice again. So let's go with the horizontal bar graph. Now, fine, it has activated some charts and I created a horizontal bar graph. Well and good. Why is it that I'm not able to create a line chart with this data? What do you think? Just observe the lower section on the Show Me panel and try to figure out what is missing. Why is Tableau not allowing us to create a line chart? If you have guessed it because of date, then you're right. Okay, observe the lower section. Here, this part. It's saying for lines chart, we need at least one date field. And here I did not select any dates. If I choose the date field, now it has activated the chart. So it will consider the fields which are already present in the graph. Along with that, it will consider the new fields that you would be selecting in the data pane. For a combination of all of these fields, it will activate the charts which can be created. In this case, line chart is now possible. Why is it that I cannot create a geographical map? Because I didn't select any geographical data. If I choose geographical data, you see now I can create a geographical map by clicking on it. So that is the beauty of Show Me panel. Okay, it will tell you what fields are required to create a particular chart. And when you select the fields, you just have to go and click on the chart in the Show Me panel and you can see the chart created. But after you have completed using it, it's better you close it. Okay, you keep it hidden all the time. Open it only when you're using it. Rest of the time, keep it hidden. So that's the purpose of the Show Me panel. Let's go and see what we have covered today. In this video, we talked about dimensions and measures. Okay, these are dimensions and below this line, what we have are measures. We talked about the difference between discrete and continuous fields. And very important point here is if you have continuous fields, which contains a range of values in it, then you will get it as a green colored pill in Tableau. And in the graph, you'll get an axis with a range of values. And if it's discrete data, which is mostly dimensions, the color of the pill will be blue. In the chart, you will get labels, which will come up on the head. Okay, let me go back to the point. Yeah. Okay. So this is what we have understood. We also talked about the Show Me panel, its purpose. So the key takeaways in this chapter is we understood about the Tableau user interface at worksheet level. We looked at the difference between dimensions and measures, discrete and continuous data, understood about the purpose of rows shelf and columns shelf. We also now know about the Show Me panel. So I hope this video was informative. Thank you all so much. I will see you in the next video where we shall continue with a few more concepts. Thank you.
Hi friends, welcome back. In this video, we will try to understand about how to create text tables in Tableau. Now, even before we go ahead and look at how to create text tables, let us talk about when to create a text table. Or where do you see text tables in your day-to-day life? Mostly where money is involved. If you observe, most of the financial reports are text tables, like balance sheets, profit and loss statements of organizations, your credit card statements, banking account statements, the income tax returns forms, data that you fill in there, right? Or for that matter, the bills that we receive, utility bills. Let's say you go to a mall and purchase something, then the receipt or the bill that you receive over there. So wherever money is involved, or in a way, wherever we have an eye for detail, wherever attention to detail is important, where the actual value is more important for our analysis rather than a quick comparison, that is where text tables come in handy. And text tables are referred to as cross tabs in Tableau. Okay, so in Tableau, if you hear the term cross tab or someone asks you to create a cross tab, they are simply referring to a text table. The structure of the table is something that you can decide by taking various dimensions into the columns and the rows shelves. So when you take something to the columns shelf, we saw in the previous session that members from that field will be arranged as columns. And when some pill is taken to the rows shelf, members from that field appear as rows. So you can decide what should be the structure by making use of the columns and the rows shelves. And the data that we put into that table should be taken into the text shelf. Of course, these are numbers, but when you take it into the text shelf, the numbers will appear. So let me switch to Tableau and show you how to create a text table. Let's say my requirement is to look at the profit across different years and different subcategories. So I need to make use of the date pill and I need to make use of the subcategory field. And I would like to look at the profit. So here is the profit measure. From the question that is given to you, first try to identify the fields. Once you have identified the fields, now you can start experimenting. Okay, I'm going to take order date to the columns. What will happen now? Tableau will arrange the members, the years present in the date field as columns. Okay, and I'm going to take subcategory into the rows shelf. So each and every member in that field, each and every subcategory appears as a row. And ABC is automatically generated. Okay, it comes when you have a chart with only dimensions used. And when there's nothing in the text shelf, ABC will appear. So in the marks card, you look at this option here, automatic. It's actually a drop-down list. Okay, but there are different mark types that we can use. Now, every data point in Tableau is referred to as a mark. Here, mark type is automatically T. T stands for text. T stands for text. Okay, that is exactly what we need, right? We need a text table. So I'm going to take profit into the text shelf. When I drop it in the text shelf, you will notice how Tableau displayed profit from each and every subcategory across different years in this chart. Okay. Another way of doing it is we can take profit and drop it directly in the table. That is also fine. Either way, you will get the same result. When I took profit directly into the table, Tableau automatically made an entry for the profit bill in the text shelf. Right. So whatever method is convenient, you can choose that method and do it. Now, what else? How do we enhance this table? What else can we do here? Let's say I would like to show the totals. I would like to see the total profit per year and the total profit from each subcategory. In that case, we go to the analysis option on the menu. And from there, we can go to the totals option. And from there, we can choose what we might want to display. In this case, row grand totals. You see, row grand total has appeared. So the summation of the data in this row, basically the overall profit from accessories, overall profit from appliances, so on and so forth. Now to display the totals, there's one more thing that we can do. We could go to the analytics pane, and from the analytics pane, we can drag the totals option and then drop it in the respective box. Here, I would like to see column grand totals. So I'm going to display column grand totals like this. Look at that, column grand totals. Okay, this is the total profit from 2019, 20, 21, and 22. And this cell or this box here is indicating the overall total, the overall profit across all subcategories and across all years put together collectively. Okay. Now what else? I'll do one thing. I'm going to bring category and I'll place it before subcategory, not after. You see the small triangle icon coming up there, right? It means I'm placing category here. I don't want it here. I'll take it here. Now, if I place it here, I would be replacing subcategory. Look at that. I replace subcategory. That's not what we are trying to do. So if I want category before subcategory, look at that now. When I take it there, look at the small triangle on the top and look at the subcategory pill moving a little bit, right? So you'll have to drop there. Okay. So now we can see the profits, which are also grouped by category, like furniture, office supplies, and technology. In such graphs, we might want to see the subtotals as well, right? So how do we display the subtotals? Very simple again. We can go to the analytics pane, drag the totals option, and now I will put it in the subtotals block. We have already displayed grand totals and row totals. That is why they are inactive, because they are already there. I'm going to put it here in the subtotals option, okay, under this option. And now you can see the subtotals. This is the grand total and this is the subtotal. We can do a lot more things over here with respect to formatting. See, these are all profit figures, right? Profit values. So, and this is United States Superstore data. So this is basically dollars. What if I want to prefix these numbers with a dollar sign? So we will have to simply right click on the chart, select the option to format. And once we choose the format option, the formatting pane will overlay the data pane. On the left side of your screen, you can see it. Here, we must choose the field that we wish to format. I would like to format the profit. Then, exactly which numbers are we trying to format? The default numbers or the totals or the grand totals? You need to be very specific. All the default numbers. So I'll go there and customize the currency. Currency custom. Here, we can represent it the way we want. So I don't want to show any decimals. I will reduce that to 0. You can decide how you might want to show negative values. You can show negatives like this, you see, in brackets. Or you could show negative like this, with the minus symbol before the currency symbol, or postfix it like that. Or you can keep it like this, the currency symbol followed by that negative sign and then the value. Anything is fine. So here, the other option is display units. We can round it off to the nearest thousands. We can round it off to millions, billions. We have such option. Here, millions is not making sense. I'll keep it as none. Okay, I'll just keep it as none. Next, prefix. For me, my system locale is India. So it is taking rupee symbol. But here, this is data from United States Superstore. So we need to put a dollar sign there. I'll simply replace this with dollar. And then I'll give a small space also, because after dollar, I would like to see a space and followed by that the number. The last option that you can see here is include 1000 separators, which happens by default. That is why you can see a comma, right? 7,145, 2,296. If we disable this, I mean, if we uncheck this option, then 1000 separators are gone. So if you want them, you can keep it. If you don't want them, you can remove. So these kind of things we can achieve very easily by using the format option. Okay, what next? Let's say the font. No. Okay, let's say the shading. Okay, let's go to shading now. I would like the totals to appear with a different shade. So I'm going to the total part. This is the icon for shading. Under totals, pane and header. There are two options. Let's change pane. Let's give this shade. Look at that. This is the pane, okay? And if we change the header, you see this is the header, total. Next, grand total. Let's indicate grand total with a different color. So I will use this color for grand totals. You can see the change happening in the chart. And always use light shades, subtle colors. Don't use very bright colors. It will not look good. Okay, so job done. Like that, we can highlight certain things that might be necessary. Now, coming to the font. Okay, you can also adjust the font of the pane, the header, alignment, shading, lines or borders you can give. Okay, let's say for total, I want a nice thick border like that. Look at that. Fine. Header also, we want a nice thick border. We can do it. And what about grand total? It also came automatically. All right. So this is row divider and column divider. If I make it 0, it will be like that. If I increase it, you see, you can just reduce the row divider if you want the borders very, brightly appear there. So yes, this is how we can do a lot of formatting as well. Do explore the formatting feature thoroughly, because there are many things that we can do here, not just 1 or 2 things. There are so many things that we can do. All right, so let me close this. So this is how we create a simple text table by taking the dimensions into rows and columns shelf, which decide the structure of the table, by taking the data into the text shelf, and you can display totals if you would like to. You can also do formatting, which we have seen. All right, so far I hope it's clear. I would recommend that you pause the video here and try it out. Okay, just try it out once from your side. If there are any doubts, you can refer back to the video. So it's good that you practice, because that is what will make you perfect at the end of the day. Let's proceed to the next concept now. We have seen text tables, but we are also going to talk about highlight tables. Okay. Highlight tables are just like text tables. Okay, you're just simply going to highlight the important information by using a background color. Each cell is given a color based on the value that it represents. So by doing this, by adding color to the table, color not just any generic shading like I did with formatting in this graph, but color which is decided based on the data in the table. Then it will be much more easier for people to read and understand, to highlight or to recognize the highs and lows. Okay, we are basically going to help make it easier for people to understand the data. So let's learn how to create a highlight table. All right. Let's say for highlight table, my requirement is to look at different measures across subcategories. Okay, different measures across subcategories. So across different subcategories, I would prefer taking it to the rows shelf, because when I take it to columns, it will look like this. Okay, so let me take it to rows. I want them as rows, and I would like to look at various measures now. So first, let's show profit. I'm going to take profit into the table, or we can take it to the text shelf. Both are fine. Okay, let me take it to the text shelf first. Here it is on the text shelf. All right. Now we can see the profit figures, right? You can see what is the profit from each and every subcategory. But by observing a little more closely, we understand that copiers is the most profitable member. Tables is the least profitable member, right? It's taking a moment for me to understand that, because I have to, in a way, scan through the entire data, and then only I can understand what is the highest and what is the lowest. Instead, what if we can somehow color this? Okay, color it based on profit, which is what we'll talk about. But before that, we'll discuss a few more things. So here is a table which is showing me the profit. Now I want to show sales as well, because we are talking about showing different measures. So I need to include sales. how to do it. One option is to take sales into the text shelf itself. But when we do this, Tableau is going to display both profit as well as sales in a single cell. Okay, this is called a cell. So within a cell, it is showing me both profit and sales, which may not be very neat way of representing the data. People may get confused on what is profit and what is sales here, right? So rather than taking sales in into the text, I'm going to remove it from here. I will take sales and drop it directly inside the table. So when I leave sales on the profit column, please observe that there is this border, okay, this thick rectangular border or outline. Only when that border appears, you have to leave the pill here. So what am I doing? I've taken sales, which I will drag and drop on the profit column. And when I do this, Tableau has made sales appear as a separate column. But a lot of other things have happened, right? Did you all notice? Let me do it again. I've taken sales into the profit column and I'll drop it in the table. Okay, on the profit column. And what happened? You will notice that Tableau has used something called as measure names here in the columns shelf. It has used measure values in the text shelf. It's no longer just profit. And it has given us a measure values legend. It's given us a measure values legend where we can see both profit and sales. What are these fields? What is measure names? And what is this field measure values? What does it represent? Okay, these are called as generated fields. Okay, so whenever you get connected to any data source, we know that the fields from the data source are segregated into dimensions and measures automatically, right? Dimensions and measures. But in addition to the fields coming from the database, Tableau gives us 5 extra fields, which are referred to as generated fields. They are measure names, measure values, latitude, longitude, and count. Okay, so what are these generated fields and why is Tableau giving them to us? Just to help us. They are very, very helpful. Measure names is a generated field that contains the names of each and every measure in that connection. It contains the names of the measures. So what are the names it will contain here? Discount is one name. Profit is one name. Quantity is a name. Sales is a name. Measure values is a field that contains the data that is present in each and every measure. See, here discount field holds the discount information. Profit field holds the profit data. Sales field holds the selling price. Quantity holds information about the number of products sold, quantity. But measure values is a generated field which contains information present in all the measures. Think of it like a superset. It has information about discounts, it has information about profits, it has information about sales, it has information about quantity, everything put together. And whenever we create a chart with multiple measures in it, here in this case, more than one measure is there, right? 2 measures are there. It's definitely more than one. So whenever we create any chart with multiple measures and a common header, for both of them, the header is common, subcategory. So in such scenarios, Tableau will automatically make use of measure names and values wherever applicable. Okay, we don't even have to worry about it. Wherever necessary, it will automatically use them. Count is also a generated field that contains information about the number of records in that table from that connection. Latitude and longitude, they contain the geographical coordinates. latitude and longitude coordinates for various geographic locations across the earth, which Tableau recognizes. Okay, so these are the 5 generated fields. Now, here is a table with profit and sales. I'm going to take discount also into the table, and I'll take quantity also into the table. Right, so we have multiple measures. And what is the sequence in which they are arranged? Alphabetical order. They have D first, then P, Q, R, S, right? So it's going in alphabetical order. How to rearrange the members? Is it possible to rearrange them? Definitely yes. You can interchange them here in the measure values legend. Let's say I want profit after quantity. I'll drag and drop it after quantity. Now notice the small triangle icon there, this orange color. It means I'm putting it here, okay? Accordingly, it got rearranged. Let's say I want discount as the last column. I'll drop it below sales. Look at that orange colored arrow kind of a thing there. It got rearranged. So summation of the products purchased, overall profit, overall sales is fine. But summing up discount is not making sense. Generally, people would want to know average discount, right? Not the summation of the discount for all the rows. So discount cannot be 571%. Discount cannot be 138%. The reason why we are getting it like this is because the aggregation is not correct or not relevant here. I will change it. So how to change the aggregation is you go to the pill, click on the drop down icon and navigate towards the measure option. From here, I'm going to choose average. But it's all showing zeros. Now what happened? Does it mean we've given zero discount everywhere? That's not the case. It simply rounded it off. Remember, when we talked about the data, I showed you that discount holds the data in decimal format, right? Like 0.2 is 20%, 0.8 is 80%. And Tableau is rounding it off and taking only the decimal, the integral part. It's ignoring the decimal part. That is why everything is coming as zeros. Now what to do? Let's format it. Okay, I'll right click on it and I'm going to format it. And I'm going to show the information as percentage. So we'll have to choose the field that we are trying to format, which is average discount. And I want the numerical representation of discount to come up as percentages. Look at that. And let's say I don't want decimals. So I will reduce the decimal places to 0. So this is the average discount represented as percentages. Okay, again over here, I would recommend that you pause the video and try these steps before we proceed further. All right, so we are looking at the quantity, profit, sales, and discount across different measures. But this is just like a simple text table. We need a highlight table, right? We need to bring in the color to help people understand this data easily, more comfortably. So what to do? We need to make use of the color shelf. I'm going to color it based on the measure values, right? Based on the data, we would like to color it. So the next step is to take measure values into the color shelf. Here, I'm dragging it into the color shelf. But what Tableau did is it changed the color of the text, of the numbers. We don't want that to happen. We want the color of the background to change. The cell should change in color. We need a color to be given to the cell. So how to achieve this? There is a workaround that we'll use here. We are going to change the mark type to square. So once I make it square, the cells are colored. Okay, now you might be wondering, why is it showing only gray color for discount, gray color for quantity? Let's try to understand how did Tableau give colors to each and every cell present in this table. Look at the right side. Look at the color legend. It is taking the complete range of data present in the table. The minimum value being a loss of 17,753, which is coming from here, from tables. And the maximum or the highest value is so-and-so number, which is basically the sales of chairs. So Tableau has considered the entire data in the table. And based on the complete range of values, the minimum and the maximum and whatever we have in between, right? Based on the complete range of values, it has given a color, which doesn't work. It's not meaningful to give color based on the entire data, where each column is indicating a separate field altogether. Colors should be based on the data present in each and individual measure. Based on the data in the profit column, I need to give color. Based on the values in the sales column, we need to give color there. So how do we do it? We need a separate color for each measure. For that purpose, now if I go to the measure values field associated with the color icon over here, there is an option called as use separate legends. All I need to do is select this option, use separate legends. Now you can notice how it has separated the legends. Color for each column is based on the data in that column. 242 is the minimum quantity here, and maximum is 6071, as you can see. By default, Tableau will give blue. Okay, it is configured to give blue. So what if we might want to change the colors, give different colors to each of these columns? How do we edit the colors? Simply double click on the color legend. Okay, go to the right side. You can see the color legend, right? Double click on it and it opens this box. You can pick up a color of your choice from the palette. Let's say I would use purple for quantity. Okay, and I'm going to double click on profit. I would like to use red and green diverging for profit. Like that you can choose. Now sales. You notice that the color is also a continuous gradient. Sales pill is a measure. It is a green colored pill which represents continuous data. So the color is a continuous gradient here. Okay. We can also click on this color box and pick a different color if we want. Okay, we can also pick it from here. Let's say I want this color for sales. And we could use step color. Rather than continuous gradient, you can use steps. I'll use 4 steps. Let's apply and see. You see? Step color. If I reduce it further, let's see 3 steps. So lower values are coming all in white color, medium range values and high range values. Without step color, it's going to be a continuous gradient. Data will, based on the values, the color is coming. Okay. So let's change for average discount also. I'll use a different color. Okay. There. So this is how you can create a highlight table with multiple measures in it. Give a color to each column depending on the data in that column. So we did not just talk about text tables and highlight tables. We also talked about generated fields, right? The measure values field, measure names field, count field, which indicates the number of records from each table. Then we talked about latitude and longitude, which contain the coordinates for different locations across the world. That Tableau recognizes, okay? Not everything, but what Tableau recognizes. So that was, so that's it, friends. That's about text tables and highlight tables, which we understood today in this video. So please do practice as much as possible, because the more you practice and the more you explore, the more command you will get on the tool and the more confident you will become. Okay, I hope the video was helpful. Thank you all so much. So I'll see you in the next video in this series. Thank you. Bye-bye. MG. So as a part of this series, in this video, we will try to understand about variety of charts that we can create to perform comparison. In the previous video, where we talked about text tables and highlight tables, we discussed about generated fields also. We understood that when we create a chart with multiple measures in it and a common header or a common axis, Tableau will automatically make use of measure values and measure names. Similarly, there's another generated field, count. Count will give us the total number of records in a table. Okay, We did not do a deep dive into latitude and longitude. I will revisit this concept when we get to geographical maps. And in this video, I will show you one more example where we will see how measure names and measure values are used. Okay, so the agenda for this video is basically to understand the variety of charts that we can create to perform comparison at a glance, to be able to understand the highs and lows in the data. And the most popular chart for categorical comparison, for relative comparison, is a bar graph. Let's say there is a business which is operating across different regions, and I would like to understand which region is doing well and which region is not doing so well. So by creating a bar graph, we get a picture of it. There are a few examples cited here. Volume of shirts in different sizes. How many sizes do we have which are of double XL? A bar indicating the number of shirts of size XL available in store. How many shirts of size L or medium or small are available? So when you have to simply compare and see, you can go ahead and create a variety of charts, bar graph being the most popular of them. Let's see how to create a very simple bar graph. This is what it looks like. You can see these, right? These are referred to as bars, and this particular chart is called either a bar graph or horizontal bars. You can also call it horizontal bar chart. So I'll switch to Tableau. I'm already connected to the orders table from Superstore, and my requirement is simple. Across different subcategories, I would like to look at the sales. You can notice that I dragged subcategory to the rows shelf. Why to the rows shelf? Because I want the members to be arranged as rows. Now I will take the sales measure and put it in the columns shelf. So there, sales being a continuous field, green pill, it will form an axis with a range of values on it. So how do we read this chart? We got the horizontal bars. Look at the marks card and observe the mark type. Automatically, Tableau has chosen bar as the mark type over here. So this is a horizontal bar graph. Why am I calling it horizontal? Because the orientation of the bars is horizontal. At a glance, I can understand that phones and chairs are doing really well. And I can understand that the sales from fasteners is very less. I can do a relative comparison. I can tell you that accessories is better than appliances. Appliances is better than art. Art is not as good as binders, right? Relative comparison or categorical comparison is possible. Now, instead of keeping subcategory in the rows and sales in the columns, suppose I swap. This icon is the swap icon. It will swap rows and columns. It will move the fields present in the rows shelf to columns and fields present in the columns to rows. So basically, it interchanges the fields. Observe this chart. Subcategory is in the columns shelf. So each subcategory is appearing as a column, and sales, which is in the rows shelf, has formed the y-axis with the data cutting across rows. What is this chart called? This is called as a column chart, or you can also simply call it as vertical columns. And how do we read this? The height of the bar indicates the value. So we can understand that chairs and phones are very good with respect to sales. Very little sales is coming from fasteners, and all the other members we can notice, right? Now, how else can we enhance this chart? What can we do to make it easier for people to understand this data? Let's give a label. Okay, see, every data point in Tableau is called a mark. Okay, here mark type is bar. So this bar, every data point for that matter, is referred to as a mark. Now I am talking about giving a label to this mark representing the value that it indicates. So I'll have to use of the marks label shelf. Understood? Because we are talking about labeling the marks, we will use the label shelf present in the marks card for mark label. All right. So let's label it with the sales value. I'm going to drag sales into the label shelf. You can see that the labels have appeared. Okay, what else can we do here? We can use color. See, each of these subcategories, they belong to some category or the other, right? Some of them belong to furniture, some of them belong to technology, some of them belong to office supplies. So let's indicate that with color. How to do it? I will take category and drop it in the color shelf. Look at the colors now. And whenever you use any field on the color shelf, Tableau will give you a color legend. Okay. And when this will be visible provided the show me panel is closed. In case your show me panel is open, then you'll not be able to see it. That is why it is better to keep the show me panel closed at all the times. Open it only when required. Now here furniture. So members which belong to furniture category are in blue color. Members which belong to office supplies are showing up in orange color. Members belonging to technology are showing up in red color. And notice one more thing here. When I select any member from the color legend, relevant data is getting highlighted in the graph and the rest of the data is dimmed out. This is the highlight feature of Tableau, which is active by default from the color legend. So when you select a member on the color legend, relevant data is highlighted, rest of the data becomes dim. Okay. That was just an additional point here. All right. So we've labeled them, we've given a color to them. Let's say I would like to give a size to these bars and I want the size to indicate the profit. So I'll take profit to the size shelf. Look at the thickness of the bars now. So copiers, which is the thickest because it is having the highest sales profit. This is the most profitable one. And tables here, which is very thin, is the least profitable. It's actually giving a loss of 17,725. Okay. So if you feel it is confusing, then you don't size it. Okay. I'm just trying to demonstrate that it's possible to control the size also. So let me do one thing. To make it easier, I'll take profit to color. So now we can understand whichever bars are in blue color. Look at the color legend. So when we use any field in the color shelf, and if it is a green pill, dealing with a range, dealing with the range of values, we get a color legend. And if this range has both positive and negative values, right? In this case, we know that there are some categories giving profits, some of them giving loss. So in that case, it is centered around 0. From 0, positive values are coming in shades of blue. Very dark shade of blue is given to the most profitable member, copiers. And from 0, negative values are going to come up in shades of orange. So this is a very bad loss here. Okay, this is a loss. This is also giving us a loss. So let me show you the profit values here. I will take profit to size as well. Now I think it should be clear, right? Blue and thick bars meaning they are profitable. Orange and thin bars meaning it is giving a loss. So I will take profit also into the label shelf. Look at that. Sales and profit. Okay, we may not always create charts like this. Just to demonstrate the purpose of color and the purpose of size shelf, I've given you this example. Generally, you can keep it simple like this. Now, one thing that you can try from your side. Okay, I will use category in color now. One thing that you all can try from your side is pause the video here and create this chart. After creating the chart, click on the label shelf and explore the options that are available over here. It's very easy and pretty self-explanatory. Okay, just try it out, and if you all have any doubts, you can leave a comment. or you can get in touch with the team. Will help you out, not an issue. But I think all of you will be able to understand each and every option available over here. Just explore it from your side. You will, it's really nice when it feels nice when we try something and learn it by ourselves. It's a very simple thing. Do explore. Okay, so this is column chart. We discussed about horizontal bars and vertical columns. Now what we'll do is we'll try a different representation of this data. Okay, so we've seen bar graph. Let's look at a dot plot. So what is a dot plot? It is just like a bar graph, but rather than having bars which indicate the value, we will replace it with circles. So I use the mark type as circle, which gives me a filled in circle. And this is referred to as a dot plot. Okay, this is referred to as a dot plot. Unlike in a bar graph where we had the complete bar, right? Here we are getting only the circle, the dot. So there's nothing tying it back to the member that it actually belongs to. We need to be a little more keen in our observation when we are presented with a dot plot. Okay, you have to observe and then understand which data point belongs to which member. So that way it might be a little bit of a burden, but if you have multiple requirements on comparison, rather than creating bar graph for each and every requirement, you can try a variety of charts like this. So this is a dot plot. Now in the same graph, I am going to change the mark type to circle, to shape, which will give me a circle view. Let's see. I'm going to change the mark type to shape. So when we use mark type as shape, that is when we get a proper circle, not a filled in dot, but a hollow circle. And how do you read this chart? It's the same as a dot plot or a column chart, right? Here, the position of the circle is telling you about the value. So if a circle is way up, it's indicating high sales. If a circle is way down, low sales, and these are medium sales. Just another different way to represent the same data. And notice the marks card now. Do you notice anything new? Do you see something new in the marks card? You might have noticed, right? So when I use the mark type as shape, there is a shape shelf which has come up. And when I click in the shape shelf, you will notice that there are a variety of shapes that we can use. Let's say I want a star to indicate my data, or I want a plus sign to indicate my data, or I want a cross mark to indicate my data. Getting it? There are no special names for these charts. There's no special name, but you can try different shapes also when you're using shape as the mark type. The default shape, however, is a circle. So horizontal bars, vertical columns, dot plots, circle views, all used for comparison. Let's see one more chart, side by side bar graph. Okay, for this, what I'll do is, this is region. Across different regions, let's say I would like to look at the sales. So I have a set of bars indicating the sales. Now, I would like to display profit as well. So we have a separate axis for sales and the bars indicating the sales across regions. We have profit axis and a separate set of bars indicating the profit across different regions. Rather than showing them as two sets of bars, one below the other, one at the top and the other at the bottom, we can also take these over here. Side by side. We can place them side by side. Now, how do we do that? Just go to the Show Me panel and click on this chart, the one in the third column, third row. This is called side by side bar graph. And when you create a side by side bar graph, what is happening is both the measures, which were profit and sales, are now combined into a single axis. Okay, so we have one axis for both the measures. And what happens when we create a chart with one header or one axis, but multiple measures in it? Tableau automatically uses measure names and measure values. So wherever relevant, Tableau will automatically use measure names and measure values to get the desired chart, to give us the desired chart. Okay. So now it's easier to compare, right? Profit, all the blue colored bars, and sales bars are coming up in orange color. All right. So this is side by side bar graph. I hope you'll understood. And when you're dealing with such a chart, right, where you're dealing with multiple measures, don't drag and drop fields into the label shelf if you have to label them. Because when I drag and drop, what happens is all the marks will get labeled with that value. See, this is profit and this is sales, but I put profit in the label shelf. So all the marks are labeled by the profit. Of course, we can take sales also into the label shelf. Now they are labeled by both profit and sales, which is not very appropriate. So how do we handle such scenarios? What if I have to label these bars in such a way that wherever there is a profit bar, we should indicate only profit value on it. Corresponding to sales bar, only the sales value should come. How do we achieve this? It's very simple. All you need to do is click on this T icon on the toolbar. It is to show mark labels. So when I click on that, Tableau will label the bars appropriately depending on the way on the value that it represents. Okay, hope you all understood it. When you're dealing with multiple measures, the normal label might not work. You can use show mark labels option on the toolbar and achieve it. So this is side by side bar. Profit and sales are placed side by side. For easier comparison also it helps. Now we'll look at one more chart that helps us with comparative analysis. So we looked at dot plots, we looked at circle views. We're now going to look at a bubble chart. Bubble chart is something which will also allow you to perform comparison, but it is a chart where we see the data as a cluster of circles, a collection of circles like that. How many circles are going to be there? How many bubbles are going to be there? It depends on the number of members present in the dimension. Each member will be indicated with one bubble or with one circle. What should be the color of the circle? And what should be the size of that circle? That is controlled based on the measure value. So depends on what you take into the color shelf and what you take into the size shelf. To display the data in a cluster of circles, we use bubble charts. Okay, so some examples are also cited over here. Let's go ahead and see how to create it. If you observe this chart, we don't have anything arranged as columns and rows over here. There's nothing in columns and rows because there is nothing arranged as columns and rows. It's just a cluster of circles. It is a collection of bubbles put together. So here we're not going to use columns and rows. Then how do we create it? We can do it very easily by taking the help of the Show Me panel. Let me demonstrate it now. Bubble chart. Let's say across different subcategories, I would like to look at the sales. That's my requirement. So I selected subcategory and the sales field. Now I'll go to the Show Me panel and click on the bubble chart icon, which is the last chart in the Show Me panel. Job done. Tableau has created the packed bubble chart. There will be 17 bubbles because we have 17 members in the subcategory field. And what did Tableau do? It has taken subcategory into color also. That is why each subcategory is coming up in a different color. Sales is on the size shelf. Look at the icon. which means the size of the bubble is indicating the sales value. Bigger the bubble, higher the sales. Smaller the bubble, lesser is the sales. Let's not color it by subcategory. I'm going to color it by profit. So I'll take profit into the color shelf. It will replace subcategory. Okay, so now the color of the bubbles is indicating the profit. Dark blue meaning very high profit. Orange meaning very bad loss. Okay, now you might be thinking, you might have a question in your mind. You can notice that some of these bubbles do not have their name written on them. We can see phones here, we can see tables here, but this doesn't have a name. That is because Tableau will not allow the labels to overlap with other marks. Suppose I have to label this particular mark, envelopes, it will start from here and extend till here. It's going to overlap with the neighboring marks. In such cases, the mark labels will not appear. So how do we make them appear? You can click in the label shelf and select the last option there. Allow labels to overlap other marks. Now you can notice that even though the label is slightly overlapping, the labels have at least appeared. And by clicking on the label shelf, you can adjust the font size, you can make the labels bold. Okay, these kind of things, of course, you can do. You can increase the font size, etc. So do explore the options in the label shelf for more understanding about it, okay? So bubble chart is another chart that helps us to perform comparative analysis. Now, can you all answer the question when to create a bar graph? When would you create a bar graph or a column chart? When you have to do comparative analysis. All the charts that we have seen in this video can be created when you have a requirement related to comparison, relative comparison or categorical comparison. Any of these charts are fine. Okay, you can create anything for comparison. So I hope you all understood when to create these charts and how to create them. These are very, very simple and easy charts. So thank you all so much. And please do practice, because only when you practice, you will get familiar and more comfortable with the tool. Because if you're only going to watch and not practice, then these things may not register well in your mind, okay? So it's a request that if you are serious about learning Tableau, please. Hi friends, welcome back. In the previous two videos, we had discussed about how to create text tables and highlight tables. Text tables or highlight tables are created when we have an eye for detail or when attention to detail is important. Then we also talked about how to create bar graphs, column charts, dot plots, circle views, bubble charts, which are all used for comparison. They come under comparative analysis. In this module, or in this video rather, we will be talking about how to create pie charts and stack bar graphs. So before we go ahead and start creating it, let's discuss or try to understand when to create a pie chart. This comes under something called as composition analysis, or what is your data composed of. You can also call it as part to whole analysis. Part to whole analysis. Composition analysis. Composition analysis. Or simply, let's not use such big terms, simply to show the shares, to show the ratios. You can use a pie chart or even a stack bar. Now, what do I mean by these terms? Let's try to understand that. Now, let's say this circle is indicating the overall 100% profit made by a business. But this profit is coming from various regions. So this is the whole profit, the complete profit, the whole. What is it composed of? What is the share of each region in that profit? All of those parts are coming together and giving us the whole profit, right? So in this, what is the contribution of central region? So let's say this much of profit is coming from central region. So this slice in the pie, this part is the contribution of central region, or let's say this is the share of central region towards the profit. Let's say this much, okay? This slice is the contribution of east region towards the profit. This slice here is the contribution of west region towards the profit. Okay, and let's assume that the remaining part, this is the contribution of, what else we have, south. Okay, southern region towards the profit. So what are we showing? If the overall circle is indicating the 100% complete profit made by the business, we are showing the shares. What is the share of central region in this? What is the share of east region? What is the share of west? What is the share of south region in the overall profit? Or how each part, okay, how all of these parts have come together to make the whole profit. Or what is the profit composed of? It is composed of smaller chunks of profits coming from various regions. Okay, I hope the concept is clear. Pie charts are created when you are performing part to whole analysis, or when you are simply trying to show the shares. What is the share of each member in the total value? Okay, now there is another way in which we can visually represent such data. We could go with a stacked bar graph. Okay, let's say this bar or vertical column is indicating the overall profit made by a business, overall profit. Now this profit is coming from customers who belong to different segments, isn't it? So we have consumer segment customers, we have corporate segment customers, we have home office segment customers. All of them contributed to give us the overall profit. Now, what is the part of each member here? Let's say in this whole profit till here, this much is the profit from consumer segment. This much is the profit from corporate segment, and this is the profit from home office segment. All of them collectively is the overall profit. Okay. Can we say that home office alone is giving us so much profit? No. Home office is stacked on top of corporate, which is in turn stacked on top of consumer. So just this part is home office, but the overall height of the bar is the overall value. Okay, stack bar can be a little tricky. I hope you're all able to understand what I'm trying to say. Imagine like the game which kids play, small children, they build a tower, right? They have toys like tumblers. So they stack these tumblers one on top of the other. Each tumbler would be of a different size. So they start with the biggest one. Then on top of that, they put one more tumbler. Then on top of that, they put a smaller one. Then on top of that. So by putting these tumblers one on top of the other, they build a big, huge tower. No single tumbler in that tower is that tall. They are stacked one on top of the other, isn't it? These tumblers are stacked one on top of the other, and by stacking them like that, they create a big tower out of it. So similar to that, you have to interpret a stack bar. Contribution from different members put one on top of the other. What is the advantage of creating such a chart? We know what is the overall value. At the same time, we have an understanding about individual contribution. What is the share of each member in this? What is the contribution of each member towards the overall value? Okay, so when you have any questions related to showing the shares or ratios, to show what is it composed of, what is your data composed of, then you can create either a pie chart or a stacked bar graph. So let's go ahead and try to create a pie chart first, then we'll learn about stacked bars. I'm going to create a pie chart now, which is used for, you can say, composition analysis or to show the shares. Now, pi is basically a circle, isn't it? It is a circle that has to be sliced, indicating the contribution. So it is not something that has rows and columns. Then what to do? We saw in the previous video. We can make use of the show me panel, and on the show me panel, we have pie chart over here. It is in the second row, the third column. So across different regions, let us say I would like to represent the profit. I selected both the fields, profit as well as region. Now for this combination, I would like to create a pie chart. So all I need to do is open the show me panel and click on the pie chart icon. Job done. And after you use the show me panel, always remember to close it. Okay, because this right side space is very important. Color legends, size legends, shape legends, interactive filters, parameters, all of them usually sit here. So you need to always keep the show me panel closed. So our pie chart is ready, right? All I did was I selected the fields, went to the show me panel and clicked on the pie chart icon, and my pie chart is ready. However, it is very small. It's not utilizing all the space in the canvas. So what we'll do here is adjust the fit. Notice this option here, standard, it refers to the fit, and I will make it entire view. Now it has utilized all the space. Okay, this is big enough for us to understand the chart. And from the color legend, we understand that blue colored slice, it's representing central region. Orange colored slice is indicating east. We have south here and west. Okay, now how do we enhance this chart? First and the foremost thing is we can label the slices, isn't it? We can label the slices. So I will take region first into the label shelf. So each slice is labeled with the region that it represents. I will also take profit into the label shelf. So we can see the profit from each region. By the size of the slice, we can understand that West region is the most profitable, and we have Central, which is the least profitable, but it's much more clearer when we label it. Okay, what next? Okay, we got the pie, we labeled the slices, everything looks perfect. How about showing these numbers as percentages? That would be even great, isn't it? Because the circle is indicating the overall profit. Now, what percentage of that overall 100% profit is coming from which region? 39,706 is the profit from Central. But in terms of percentages, what is it? How do we get it? All we need to do is use a quick table calculation. Okay, if you would want to compute percentages, you don't have to worry in Tableau, because for such things, Tableau people, they have already written the formula for us. We don't have to sit and write a formula. The formula is pre-written and it is inbuilt into Tableau. We just need to invoke it. How do we do it? I want this label, profit label, to show as a percentage, which means I will have to go to the corresponding pill, profit with label icon. T here represents label on this graph. Okay, I will click on the drop down icon of that pill. Go to the last second option, quick table calculation. And from here, I'm going to select percent of total. There are many other quick table calculations available. So if you have to get the running total or difference, etc., you don't have to write a formula. It's already written and available. You just need to use it. Here I'm going to use percent of total. Look at that. Tableau has computed the percentages and it's showing us the percentages. So Central region's share in the overall profit is about 14%. West region's contribution or its share is about 38%. South is about 16%. Okay, how to round off these decimals? I'm not interested in looking at the decimal places. I would like to round it off. So we can do such things by using the format option. So I'll go ahead, format, and percent of total sum of profit is what we are trying to format. When we did text tables, we discussed a lot about formatting. So anybody who has missed that video, you refer back to it, okay, for formatting related things. So I will go to the numbers and I will change it into, I will choose percentage and reduce the decimals here. I made decimals 0, so you can notice how it is rounded off. Okay. Now let's say I would like to label it with the actual profit also. So I'll simply have to drag profit again into the label shelf. I hope you all understood what is a pie chart, how to create it, and what it represents. So there is one more chart that we can create to show the shares for composition analysis, which is a stacked bar, and we shall see that now. Stacked bar graph. Let's say across different regions, I would like to indicate the profit made by these regions. Okay, so we can understand what is the profit from central, east, south, and west. Let's say within each region, I need to indicate the profit from different segments. See, the overall profit from central region is 40,000, nearly 40,000. So by looking at this, I know this is nearly 40,000. This is slightly over 90,000, maybe 93,000 or so. This is a little below 50, somewhere over here, maybe around 48. And this is a little below 110, maybe around 108. Okay, so I'm just telling you that by looking at the tip of the bar, we understand it. We can understand what is the profit, overall profit from each region. Now I want to show it by segment. If I take segment and place it next to the region pill on the columns shelf, what is going to happen is under each region, it is showing us the profit from various segments: consumer, corporate, home office. Under East, consumer, corporate, home office. But can we comment about the overall profit here? What is the profit from central? If that's the question, I can't give you an answer directly or just like that. I'll need time because now we're not looking at data overall profit in central, right? Within central, we are looking at what is the contribution from consumer, corporate, and home office. So this is approximately, let's assume that this is around 8,000. It's an assumption, rough guess based on this. This is maybe around 18,000. This is maybe a little over that, 14,000 or so. So when I take a rough guess, approximately 40K. Approximately 40K. And what about East region? Again, this is 40 plus maybe 30, 70, we'll say, plus another 25. Maybe around 95. It may not be accurate, but just a rough guess. So I am not able to tell you about the overall profit under central. However, if I add these three values, it is showing me in the tooltip. It is 39,706, approximately 40,000. This is approximately 91,000. Okay, how do we retain that value? So rather than showing these bars side by side, if I can put this on top of this and this on top of that, if I stack corporate on top of consumer and stack home office on top of that, we will get the overall value and then we are slicing it. Understood? The purpose of a stacked bar and how it is helpful in such scenarios. I hope you understood. So I'll remove segment from the columns. Let it be by region, but we are going to slice it based on the segment. So I'll take segment into color. Look at that. So what is the overall profit from West? Can you tell her? tell me what is the overall profit from West. Definitely, you can at least give me a rough figure. You can say it is slightly less than 110K. At the same time, can you tell me what is the contribution of consumer? Yes, 57,000. Contribution of corporate, 34,000. Contribution from home office, 16,000. Okay, so the overall height of that bar is the overall profit of West region. And then the slices are indicating the contribution of various segments. Okay, I hope you all understood stack bar. It's not a very easy chart to understand. So if you have any doubts regarding this chart, if there's any confusion, please do refer back to the video. Still, if there's any confusion, you can reach out to our team at 360DigiTMG and we will help you out. Okay. I'm going to turn on the mark labels so that you can see the labels. Contribution of each member in the stack bar. So that was about charts which help us when we have to show the shares or proportions or ratios or the composition. There is one more chart called as a donut chart, which is used for the same purpose. However, we will not be covering it in this syllabus, okay? Because that's slightly more complicated and it requires you to be familiar with calculated fields and many other concepts. So we are going to take up only pie charts and stack bar in this video. Hope you all understood it. So this is what we had learned. Right. There's a typo, there's a mistake here. This is supposed to be composition, okay? Not for comparative analysis. Sorry about that. Pie charts, stack bar graphs, and donut charts are used for composition analysis. Okay, composition analysis. Pardon the spellings also. They're used for composition analysis. All right, friends, I hope everything that we discussed in this video is clear. Please do revisit stack bars if there's any confusion. But if you have understood, then that's amazing. I will see you in the next video where we will talk about time series data analysis. Thank you so much. Bye-bye. Hi, friends. Let's continue our learning journey. We will be looking at a few more graphs in this video. So in the previous session, we understood about composition analysis or part to whole analysis, how we can use pie charts and stacked bar graphs to show the shares or proportions in the data. In this module, we will try to differentiate. We are basically going to revisit the concept of continuous and discrete data and differentiate it again. And we will look at time series data analysis, under which we will learn how to create line charts and area charts. Okay, so let's get started with what is the difference between continuous and discrete. This is something that we had already seen. We are doing a recap here. Continuous field is a field that contains a range of values, and that pill is indicated with a green color. And in the graph, visually, we get an axis while dealing with continuous data. Discrete field is something that has a distinct set of values in it. And if a field is discrete, the color of the pill will be blue. And if a field is discrete, then members from that field are displayed on the header and they are called field labels. Right. Now, why are we talking about this concept again and that too over here? Because when we learn line charts, there are two variants or varieties in a line chart. We can create either a continuous line chart or we could go ahead and create a discrete line chart. So we are going to look at the difference between the two. But when should we create a line chart? Isn't it? Given a requirement, how do you decide whether you should create a line chart for it or not? So if you are dealing with time series data, if you want to view the trends in data over a period of time, if you're looking at data that has been collected, gathered for over a period of time, then by default, creating line charts would be the best option. like stock price change over a 5-year period, website page views during a month, revenue by quarter, year-over-year growth. So for all such things, line charts come in handy. Let's see how to create a line chart in Tableau. So I'm already connected to Superstore. We're going to talk about line charts. So to create a line chart, we need to have a date field. Let me take order date to the columns shelf. And let's say I'm interested in looking at the profit. So I will take profit into the rows shelf. And look at what Tableau has done. Automatically, Tableau has given us a line. Right? We didn't go and select anything anywhere. The moment I used a date field in the canvas, and then whatever measure, Tableau has automatically utilized line as a mark type. Look at the mark type in the marks card, automatically it is a line. I will turn on the mark labels. So what do we understand? This is the profit from 2014, 15, 16 and 17. And observe the date pill on the columns shelf. It is rolled up by year. If you look at the data and check the data in the order date field, we have the complete date. Okay, we have information about the month and the year and the date. Okay, meaning the day and the month and the year. We have the complete information. All right, but when I used this field to create a chart, Tableau is not showing me each and every date present in the order date field. Instead, it has rolled it up by year. That is because dates are internally stored by Tableau in a hierarchical fashion. Date hierarchies are automatically created. Okay, and that is why you will see a plus sign. When you see a plus sign on a bill, it means you can do a drill down. When you click on the plus sign, it will drill down and take you to the next level. And when you click on the minus, it will roll up. It will go back to the parent level. So plus is to do a drill down, minus is to do a drill up or a roll up, anything we can call. Let me do it and show now. So I click on the plus sign on the year bill, it's taking me to the next level, quarter. Again, if I click on the plus sign, it takes me to the next level, month. Again, if I click on plus, it takes me to the next level, day. It is also possible to insert week in between if we want. Anyway, now I'll roll back. How do we roll back? By clicking on the minus. So when I click on minus, it comes back to that level. It drills back, drills up. Okay, so dates are internally stored as hierarchies and date hierarchies are automatically created by Tableau. Whenever you use a date field, it will be rolled up by year. Now, is this a discrete line chart or is it a continuous line chart? How to figure it out? You can check the color of the date pill. If it is a blue pill, it means this is a discrete line chart. And if it is a blue pill, what will happen in the graph? We will get a header with field labels on it. So 2014, which is one particular member, is here. 2015 is another member. 2016 is another member which I can select because it is a label. I can click and select. If I want, I can even exclude that one particular member. Okay, so this is a discrete line chart. Now, how do we make it continuous? See, when we click on the drop-down icon of the date pill, on the drop-down menu, you will find year, quarter, month, day, and more. More is used to customize the date. Again, there is year, quarter, month, week, day, and more. More is for customizing. But why is this getting repeated? Year, quarter, month, and again, it's getting repeated. That is because the first set of dates that you see here will treat the date as a discrete field. The second set, they pertain to the continuous date field. Okay, so right now, this is the year which Tableau has selected automatically. It is representing it as a discrete year. I will pick it up from here. So if I select year from this place, it is going to become continuous. How do I know that it is continuous now? Because the color of the pill is green, and green pill indicates continuous data. And data from the green pill forms an axis with a range of dates over here, with a range of years. You see, I can't specifically select one particular member because it is not a member, it is not a label, it is an axis with a range. All right, did the values change? No, they haven't. This is the profit from 2014, it remains the way it is. Profit from 2015, 16 and 17. All right, so how does it matter now? We don't see any prominent difference or significance of each of these charts, right? Both of them are showing the same data. One is a small chart, the other one has expanded and utilized the entire canvas. So that's not the true strength of each of these charts. It's not even the proper difference between them. Let me show it this way. Now I'm going to pick up quarter from here. If I choose quarter from here, it will give me a discrete line chart. This is going to form a discrete line chart. Look at the color of the pill, blue colored quarter pill, blue, meaning discrete, meaning I have labels, Q1, Q2. You see how I'm able to select what I want. It's not a continuous range. These are labels, Q4. This is the profit from quarter 1, quarter 2 profit, quarter 3 profit, and quarter 4 profit. But quarter 1 of which year? Right? Okay, quarter 1 profit, but from which year? Quarter 2 profit, from which year? This is the profit from quarter 1, that's all, irrespective of the year, because we didn't use year here. This is just quarter, which means this is the overall profit made by the business in quarter 1, irrespective of the year. This is the profit from quarter 2, irrespective of the year, means consolidated, all the years quarter 2 performance put together. All the transactions from quarter 3, from across all the 4 years put together is this. And this is quarter 4. So this is like a summary report. Overall, quarter 4 has been the most profitable quarter for this business. Overall, quarter 1 is the least profitable quarter. This is the overall performance. It gives you a summary kind of a view. By looking at this chart, will it be possible to comment about the profits from each of these quarters across each and every year? Can we conclude saying that every year, quarter 3 to quarter 4, there is a spike in the profits? We cannot come to such conclusion, isn't it? Because we don't know what is happening in each and every year. This is the overall performance at quarter level. What's happening in each year with these quarters is not clearly known to us. So what I'm going to do is, I will change this quarter and use quarter from the second set, means from the continuous set. So if I pick it up from the continuous set, look at the graph now. It is a green colored quarter pill, meaning it is continuous, which means I will get an axis with a range of dates. So you might feel that Tableau probably skipped quarter 1, it's showing quarter 2. Skipped quarter 3, it's showing quarter 4. No, it hasn't skipped. These are referred to as tick marks. And depending on the size of your screen on which you're viewing the chart or creating the chart, Tableau will decide where these markings should come. If you look at the graph itself, we do have data for 2014 quarter 1. This is quarter 2. Here, this is quarter 3, quarter 4. Again, 2015, quarter 1, 2, 3, 4. So when you go with a continuous line graph, when you pick up the date granularity from the second set, it is going to give you a continuous line chart, which is a detailed report, performance of every quarter from every year I can see here. Now look at 2016. It's a different scenario, right? Q1 to Q2, there is an increase, but Q2 to Q3, the profits have reduced. And then there's a spike. So the overall spike could be because of this. This could be one reason. And the latest year has a completely different story to tell, which is completely opposite of our overall pattern. Q1 to Q2 profits have decreased. Q2 to Q3, there is a spike. Q3 to Q4, it has maintained more or less in a stable way. Right? So a continuous line graph is like a detailed report, and a discrete chart is more like a summary report. Now, if I pick up month from here, how many data points am I going to see over there? If you think it is 12, then you're absolutely right, because this is discrete month and we have data for 12 months. One data point for Jan, one data point for Feb, for March, for April, for May. So this is the performance of the business in January. Performance of the business in February, irrespective of the year. Overall Feb, overall March performance, overall December performance. If I pick it up from here, what would happen? If you're thinking 48 data points, then you're right. Because we have data for 12 months and we have it for 4 years. In all the 4 years, we have data for all the 12 months. So 4 multiplied by 12, we get 48 data points over here. All right, so I hope you all understood the difference between discrete and continuous line chart. Depending on your requirement, you have to decide which chart to create. If you want more like a summary view, go with a discrete report. If you want a detailed view, then you go with a continuous line chart. Okay, now there's another chart that we can create for time series data analysis. We can create an area chart. Okay, so across different years, I'm looking at the profit. By default, Tableau has given me a line chart. If I change the mark type to area, this is an area chart. Simple, right? Instead of just showing the line, it is shading the space between the header or the axis and the line itself. So this complete area is filled in with a color. This is an area. But that's not actually the true strength of an area chart now. Okay, it's not that simple. It's not simply shading the color. Let's see what it is. So this is the profit made by the business across different years. Now I would like to break it down by segment. So I'm going to take segment into the color shelf. Tableau has given me 3 different lines. This corresponds to consumer segment, the profit obtained from consumer segment across different years, profit made by corporate segment across different years, profit from home office segment across different years. Perfect. So individual profit, I know 11,000 from home office, 13,000 from corporate, almost 25 from consumer. But can we tell what is the overall profit of 2014? We'll have to do a little bit of math, right? We'll have to check. Overall profit of 2017, again, I'll have to select those data points and check in the tooltip. So I no longer have information about the overall profit in each year. I know the profit from individual segments. In the previous video, we had looked at stacked bar, right? Imagine presenting this data as a stacked bar. Okay, if I were to create a stacked bar, here I'm selecting the stacked bar chart from Show Me panel. What is it doing? It gives you an idea about the overall profit, approximately 50,000 in 2014. Okay, slightly over 60,000 over here, over 80,000 over here, and more than 90,000 over here overall. At the same time, it's also showing me individual profits, stacked one on top of the other. Now, instead of stacking the bars, imagine if we considered the complete area. Okay, this is the performance of corporate segment, which is stacked on top of home office. and this is the performance of consumer segment, which is stacked on top of corporate. So I'll just connect this, then connect this, and then connect this. Imagine shading this whole area in red, this whole area in orange, this complete area in blue. Okay. By using mark type as area, I'll show it to you. Look at that. So this is an area chart. Must be a little confusing, right? So you think of it like this. Think of area chart as a combination of line and stacked bar. So instead of stacking bars one on top of the other, you're looking at the data in the form of line and you're stacking the areas. So this is one area. On top of that, corporate segment area. On top of that, consumer segment area. So think of area chart as a combination of line and stacked bar. Then it will make sense. Okay, try it out. And if you still have any doubts on this chart, do let me know. You can drop a comment and I'll get back. So that's about the charts that we use for time series data analysis. Now over here also you can create whatever you want. You can create continuous chart or you could create a discrete chart. Okay, instead of lines, we are stacking areas together. That's it. Both of them are used for time series data analysis. Okay, so we've looked at line charts. We looked at the difference between a discrete line chart and continuous line chart. And we looked at area charts. Okay, I hope everything that we discussed in this video is clear to you. Please do practice. So when should you go for a line chart or an area chart? When you have to perform time series data analysis. All right, friends, I hope it was informative and you all understood everything. So thank you so much. I will see you in the next video where we will discuss about a few more concepts. Thank you. Bye-bye. Hello, everyone. Welcome back. In this video, we will look at a few more graphs. Okay, so in the previous video, we talked about how to represent time series data by creating line charts and area charts. Here in this module, we are going to understand about geographic roles. We will learn to create geographical maps like field maps, symbol maps, and density maps. Okay, let's understand. First of all, let's understand what are geographic roles. All right. See, in Tableau, when you get connected to any data source, if there is geographical information in that data, Tableau will automatically provide us with two fields, latitude generated and longitude generated. This is called as geocoding data. It is basically the latitude and longitude coordinates for all the locations which Tableau recognizes. So does Tableau recognize each and every place on this earth? No, it doesn't. It doesn't recognize each and every location. Then what does it recognize? It recognizes certain locations which come under these geographical roles. Okay, so Tableau does not recognize each and every location. It does not internally, it does not have the latitude and longitude coordinates for all the places on the earth. It has that information, that geocoding data in its repository for certain locations which fall under different geographical roles. Now, what are the geographic roles which Tableau recognizes? Okay. Airports. So if your data set contains information about international airports, you will be able to plot it on a geographical map because Tableau recognizes all the international airports. The IATA and ICAO airport codes are recognized. Area code. This is specific to United States. So anything that Tableau recognizes specific to the US it is very clearly given by mentioning US in parentheses. This is standard three-digit telephone area code in the US. CBSA MSA. This is also something pertaining to how United States is divided into different statistical areas, which is done by the US Office of Management and Budget. And these areas are recognized by Tableau. So when I say Tableau recognizes these things, these places, these areas, what does it mean? It means that it knows the coordinates to plot these locations on the geographical map. And the coordinates are installed on your machine. When you install Tableau, it's all inbuilt. Okay. Cities. Tableau recognizes all the cities across the world with a population of 15,000 or more than that. So small villages, towns with little population, less than 15,000, they are not recognized by Tableau. However, we have a few workarounds. We have certain options using which we can still plot them on the map. All right, congressional district. This is again specific to US. Every state in the United States is divided into congressional districts. Then we have countries, all the countries across the world. And when it comes to countries, it's not just the name of the country, even the codes, like the 2 alphabetical code that is given to the names of the countries. Okay, the 2 alpha code. What happened here? The color was the problem. Okay, the 2 alpha code or the 3 alpha code. For example, if you take India, the 2 character code for India is IN and the 3 character code for India is IND. So whether in your data source you have the full name of the country or you have the 2 character code or the 3 alphabetical code, it does not matter. Tableau will be able to plot that location on the geographical map. Okay, so that's about countries. The next geographic role is county, second level administrative divisions. There was a time when Tableau recognized counties only for the US. Now it recognizes for many other countries. It recognizes counties in UK, in France, in Germany, so on and so forth. Nuts Europe. Nomenclature of territorial units for statistics. How the geography in Europe is divided into some statistical areas and Tableau recognizes them. States and provinces. Worldwide states. Okay, Tableau recognizes them. So state is basically a first level administrative division, which is divided into multiple counties, which are second level administrative divisions. And finally, zip codes. For many countries across the world, it recognizes them, irrespective of how many digits would be there. For example, in the US, there's a 5-digit zip code. Australia, there are only 4-digit zip codes. In India, we have 6-digit zip codes. Tableau recognizes them. Okay. So what I'm trying to say is, if you have information about any of these locations in your data source, even if you may not be knowing the coordinates for those locations, even though the coordinates might not be present in your data source, only the names of the locations could be there, Tableau will still be able to plot them on the geographical map because it internally has the coordinates for these locations. All right. Now let's see how to create a geographic map in Tableau. First, we will learn about filled map, also called as the choropleth map. It is a map wherein the area is completely filled up with a color, indicating some value. Okay, so the problem with the fill map, however, is that you can show only one measure. Because we would be showing the information through color, we can show only one measure. So let's create a fill map here. How to create a map? All you need to do is take the geographic field into the detail shelf. Tableau will automatically use the latitude generated and longitude generated fields in the appropriate shelves, like in the rows and columns, and invoke a geographical map, which is brought into the canvas. And on the geographical map, which is used as the background, it is indicating the data point. Now, in this particular version of Superstore that I'm using, I have data only for the United States and therefore only one single mark. All right, now let me bring in state into the detail shelf. It's going to show us data for all the states. Here, I would like to indicate the profit from each and every state. So I'll take that profit pill into the color shelf. Look at how each state is filled up with a color. Now, how do we read or interpret or understand this color? Obviously, by looking at the color legend. And we discussed about color legend earlier. When you have a combination of positive and negative values, it is centered around 0. So I have positive values in shades of blue, negative in shades of orange. Depending on the value, the shading will vary. So now I understand that California is the most profitable state, followed by that is New York, and then we have Washington. And I know that Texas is the least profitable state. All these states coming in shades of orange are giving a loss. Okay, here we can show only one measure because we are showing it through color. There's no other aspect that we can control. Okay, let me quickly make a connection to another data source, which is called as a global Superstore data source. All right. So under global Superstore, we have data for a lot of countries across the world. I just want to give you a glimpse of how things work depending on the data in your data source. So because you might have a confusion or a doubt on why did it show only the US? Why not the other countries? That is because of the data. Now, in global Superstore, we have data for a lot of countries. So when I bring the geographical field country to the detail shelf, you can notice how it has plotted all the countries on the map, the countries for which we have data in our data source. Okay. All right. So we understood about field map. I would recommend that you pause the video here and please practice field map and then proceed. Okay. I'm taking you to the next concept. Let's look at how to create a symbol map. On a field map, the drawback is that we can show only one measure through color. But what if we have to show more than one measure, two measures? If you would like to show two measures, you can try a symbol map. So I will use sample Superstore and bring country into the detail shelf. It's showing us United States. Now I'll take state. I would like to look at the data for various states. Now let me take profit into color. What will this do? It will give us a field map. On this map, I would like to indicate sales also. So I'm going to take sales into the size shelf. Immediately, Tableau has changed the mark type. Earlier it was map, now it has become a circle. So it is representing the data with a circle, which is the symbol used here. Symbol. Hence the name symbol map. Now I'll click in the size shelf, slightly increase the size of those marks because some of them are so tiny, they're hardly visible, right? So I'm going to increase the size, make them slightly bigger. Okay, this is better. Now, how do we read or interpret or understand this map? Profit is on the color shelf, which means the color of the circle is indicating the profit. Blue colored circles represent profits. Lighter shade of blue means lesser profit. Orange colored circles indicate loss. And you can see that some of these states here are giving us a loss. Some of the marks are hardly visible. If you look at North Dakota, South Dakota, very tiny data points because the sales is very less. And the color is gray, more or less gray. That is because the values are very close to 0. Here, this gray scale. Okay, this one on the color legend. So we are indicating profit with color and sales with size. Texas sales is pretty good. But what what use, right? It is giving us a loss. Similarly, Illinois, Ohio, Pennsylvania, they're all giving us a loss, even though sales is significantly good compared to many other states over here. So to make these data points slightly more visible, prominent, to make them a little more prominent on the graph, because now it's just getting merged with the background color, what I'll do is click in the color shelf and give a border. This is better, right? At least we are able to see those marks now. I'm going to click in the color shelf and also turn on the halo option, okay, by choosing a color. When you turn on halo, it becomes thicker. Basically, that border becomes a little thicker and the data points become very prominent. Okay, so this is how you create a symbol map to indicate two measures, one through color, the other through size. Now let's go and try a density map. It indicates the concentration of the values. Okay, how dense or how scarce the data points are in a particular area. So once I show you the map, it will become much more clear. Let me take country to detail, and then I will take state into the detail shelf. I'll also bring city into the detail shelf. Okay, I'm looking at various cities where Superstore has its presence, where Superstore is present. Let's think that these are all cities where Superstore has a store, physical store is there. So we can see that in this part of California, it has a lot of stores. Here in this part of California, again, a lot of stores are there. Here it is very scarce, very few stores are present. Okay, then we can see a lot of stores here in this block over here, right? And mostly along the East Coast and some areas in Illinois, some areas in Utah, you can see that stores are quite dense. Here it is very scarce, far away. Here we have a lot of stores, dense, one thick spot is there, right? So when we have such data, and if we would like to indicate the density, we can use the mark type as density. I know it's all looking really bad right now, but when you use density as the mark type, it is necessary to adjust the colors. Use an appropriate color. If you notice, there are some colors which work specifically for density mark type. And my personal favorite here is density multicolor light. It gives you a beautiful map which looks like a heat map, which is talking about the temperature, the heat in the data. So wherever you see the heat spots, these are those areas where Superstore has a lot of stores present, where the data is very dense. Okay, where the data is very dense. Lot of observations, lot of data points are there. And here and all, it is scarce. Imagine if this was COVID cases count. Okay, let's say I'm showing COVID cases count on this map. So wherever you see heat spots, those are areas where the case count is very high. Wherever you don't see heat spots, those are safe zones, right? Imagine it like that, then it will make more sense. So that is how we create geographical maps and represent geographical data on a background map to add more context to the data. Isn't it? When you present it on a background map, the map itself is kind of self-explanatory. People can understand it, read it better. So when you have geographical data, always choose to present the data on a geographical map. So when will we go for geographical maps? When you have geographical data, as simple as that. What are the types of maps that we can create? We have field map, we have symbol map, density map, which we have covered. There are many other maps that we can do, but we have covered these three things. Okay, we've understood that when you have geospatial data, geographical data, it is always good to represent that data in a graphical format on a geographical map. Hope the video was informative. Hope you are all liking the sessions and learning from it. Please do practice, and I will see you in the next video. Thank you so much. Bye-bye.
Hope you're all doing well. Hope you are enjoying this series of videos that we are doing on Tableau, and hope your learning journey is coming along really well. And I also request you all to subscribe to our channel. And if you find the videos helpful, please do like them and share them with your friends. And leave your feedback in the comment section so that we can take it and maybe, implement your suggestions. Whatever you have to say, you can let us know and we will take up your feedback. Okay, so thank you so much for your support. Without much delay, let's proceed. So in the previous video, we had looked at geographical maps, which are used to represent geospatial data. Now we're going to talk about how do we sort the data in Tableau. What does it mean to sort? It means to arrange the data in a particular sequence. We might want the members to be arranged either in ascending order or in descending order or any sort of random sequence, okay, based on your requirement. So how do we arrange the members in a sequence? That is what sort means. So let's switch to Tableau and try it out. I'm going to look at the data for various subcategories, and I will, let's say, look at the profit. Okay, or let's take sales. Okay, it'll be simple. Now, what is the sequence in which these members from the subcategory field are arranged over here? They are arranged in alphabetical order, isn't it? They are arranged in alphabetical order. And the bar is indicating the sales value. We already discussed how to understand or read or interpret a bar chart. That should not be a problem for you, right? So the length of the bar is indicating the value. Now, let's say I want to rearrange these members based on their sales information. How to sort the data? We can very easily and quickly sort the data by going towards the title on the axis, right? This is the axis and sales is the title. The moment I hover the mouse pointer towards the title, you see a sort icon appears. First click, when I click on it for the first time, data is sorted in descending order. If I click on it again, second click, data gets sorted in ascending order, increasing order. Third click, if I click on it again, it goes back to the default unsorted view where it's arranged in alphabetical order. Okay, first click descending, second click ascending, third click back to the normal view. So when we do this, exactly what is it that is getting rearranged here? The members on the header, the members in the subcategory dimension are getting shuffled. They are getting rearranged based on their sales value. So phones with the highest sales is at the top of the list. Chairs is in the second position. Storage is in the third position, so on and so forth. All right. And you will notice that the sort icon has appeared on the subcategory pill, not on the sales pill. We are sorting or rearranging the members from the subcategory dimension depending on the sales. So depending on the sales, whether it is low or high, depending on that, these members are getting rearranged. And when you change their position, they will move around. Okay. How else can we sort the data? We can make use of the sort icons on the toolbar. So when I click here, data will get sorted in descending order by sales, of course, because that is the measure used in the chart. And when I click here, it gets sorted in ascending order. How to clear the sort now? How do I go back to the unsorted view? So we need to go to the subcategory pill with the sort icon at the end. And when I hover the mouse pointer there, you see a small drop-down arrow that will help us access a few more options. Okay, I will go here and I'm going to select the option to clear the sort. So only if you have sorted the data in any sequence, Then the clear sort option will appear. And when you click on the clear sort option, you see that it's back to the original view. Now, let's say I want to sort these members based on profit. Though I'm representing sales in the chart, let's say I would like to sort it by profit. Now, how would that be possible? Because profit is not present in the graph. How can I sort it by profit? We can go to that pill, click on the drop-down icon, and choose the sort option. When I click on the sort option here, Tableau will open up a window where there is something called as sort by. By default, it is alphabetical or data source order. Now I would like to sort by a field. Okay, I'm trying to sort it based on a field. Now I have to choose the sort order, let's say descending order, and I want to sort it based on, it's taking sales, but I want it by profit. So I'll type in profit here. Look at how the members are getting rearranged. These members are arranged based on their profit in descending order. So the most profitable member, copiers, is at the top of the list. And the least profitable member, tables, is at the bottom of the list. Okay, so let me show you by placing profit also in the screen. Look at that. So this is the most profitable member. This is the least profitable member. So the subcategories have now been sorted based on their profit, which we can see. All right, I will remove profit. Generally, we don't sort it on a field that is not in the graph. We always sort it on a field that is in the chart or indicate it in some way or the other. So I can also take profit to color. Look at the gradient, dark blue to light blue to orange and dark orange. So most profitable to the least profitable. Okay, let me clear this now. I'm going to clear the sort. So we can sort it based on any field of our choice by pulling up the sort window. Now I'm going to sort it using the sort icon on the toolbar. I'll turn on the mark labels. These members are rearranged based on their overall sales, right? The total sales from phones, almost 330,000, is at the top of the list. Then we have chairs, then we have storage in the third position, we have tables in the fourth place, so on up to the last member, right? Now, I'm going to bring the date pill, which I will place before the subcategory pill over here. Over here. What has happened? What is happening is Tableau remembers the original sequence. It knows that phones is number 1. Second position goes to chairs. Third place we have storage. Fourth place we have tables. So it's memorizing this. And it is repeating the same sequence under every year, for every year, irrespective of the performance of those members in that year. The overall sequence is getting repeated. So in 2014, machines is in the third place. But according to Tableau, the default sequence is what? Phones, chairs, storage, tables. Somewhere down you have machines. Look at 2015. Over here, I have phones in the first place and chairs in the second place. However, chairs is the most profitable, is the member with the highest sales. This should go to number 1 position. Phones should come down to number 2. So what is happening? Tableau is not performing nested sort, right? Subcategory, here subcategory is nested under year. Subcategories are nested under the year field. Tableau is not looking at these new numbers, the performance of these members in that year. It's just going with the default original overall sequence. Okay, so we must tell Tableau to look at the nested information, look at the data in each year, look at the information nested under each year, then you rearrange them accordingly. So how do we do this? By performing nested sort. So I'll go to the subcategory pill.
pull up the sort window and ask Tableau to go with nested sort, nested in descending order. Now look at what has happened. It is looking at the data nested in each year. Phones, then chairs, then machines came to the third position. Based on its performance in 2014, machines is in the third place. Look at 2015, chairs is number 1. Number 2 is phones. Number 3 is storage. Number 4 is accessories. Machines is way down here. Okay, I hope you all understood the difference between a normal sort and nested. Generally, Tableau will automatically perform nested sort also. In case it doesn't perform nested sort, need not worry about it. You can go ahead, pull up the sort window, and then perform nested sort. Okay, very, very useful feature. So that is about sorting, friends. I hope you'll understood it. If you have any doubts or questions regarding sorting, please do leave it in the comment section and we'll get back to you. Please do like the videos, share them, and subscribe to the channel. All right. Thank you so much. Thank you all. Bye-bye. Hello, everyone. Welcome back. In the previous video, we had discussed about sorting, how to arrange the data in a particular sequence based on our requirement. In this video, we will focus on the concept of filtering. How do we filter the data? Now, what does it mean to filter? To filter is to keep only the data that we need for the analysis in the view. To take the data that is necessary and ignore or remove the rest of the data. So how do we put a limit to the amount of data to be analyzed is what we are going to learn now. Okay. So filter is a method of limiting the amount of data. We can put filters on all the fields in Tableau. We can have filters on dimensions, we can have filters on measures, and we can have filters on date fields. Let's begin with dimension filters. There are many ways in which we can filter the data when we use a dimension. We have some tabs called as the general tab option, the wildcard, condition tab, and there is top. Let's look at this. So let's say this is my data. I'm looking at the profit from various subcategories. All right. Now, I would like to filter this data based on the subcategory dimension. I don't need all of them. Okay, I would like to put some conditions and remove some of them. How to do it? We'll have to take the field whose members are supposed to be eliminated from here, whose members are supposed to be filtered out. We'll have to take that field into the filters shelf. So I took subcategory and dropped it in the filters shelf. Immediately, Tableau has given me this window, which has 4 tabs: general, wildcard, condition, and top. General is simple selection criteria, where you will select what you want and deselect or uncheck what is not necessary. So I am not going to select accessories or appliances or art. So when I uncheck this and apply the filter, look at the change in the background in the graph. Those 3 members which I did not select got removed. Okay, so that's general. You select what you want and you uncheck what you don't need. Then we have wildcard. Here we can give the match value, which could be a single character or a substring or the complete string. And we can use one of the 4 options. Okay, like the name of the subcategory should contain something in it, or should start with certain characters, or should end with certain characters, or should exactly match what is given. So let's say I want only those subcategories which are ending with the character S. And this is not case sensitive. Even if you give a capital S, it will work. So ends with S meaning what? I will get all of these members, but paper will not meet the condition. The wildcard criteria is not met by paper and by storage. They will get eliminated. Let's apply and see. Look at that. So I'm getting only those members which end with S. Let me go to condition tab. Here we can set up a condition. None meaning we are not setting up any condition. We can set up a condition based on a field or by writing a formula also. So if you're familiar with calculated fields, we can even write in a big complex formula here. For now, I will go by field. I want those subcategories which are making a profit of greater than 0. Meaning what? I want those subcategories which are profitable, whose sum of profit is greater than 0. Which means bookcases, which is giving a loss, supplies, and tables should be removed. If I apply this condition, you will notice that loss-making members are gone. Okay. Now let's say I want only the top 3 members meeting all of these conditions. So top is used to set a limit on the number of data points that you see. I'll go ahead and put a limit. I'll say that I want only top, let's say 3 members based on their profit. So what are the top 3 from the graph? Copiers, phones, and binders. If I apply, it is supposed to show me copiers, phones, and binders. The other option that we have here is we can select bottom. So it will show me the bottom 3 members now. Okay, let me apply and show. It will be the other way around. Okay, so let's go back to top 3. Apply. These are the top 3. At any given point of time, if you have any doubt or any confusion or exactly what has been done here, you simply go to the General tab. And on the General tab, you can find the summary box. So the field whose members we are trying to filter out or eliminate is subcategory. Manually, I selected 14 out of the 17 values. I'm asking for those members which end with the character S. And on top of that, they should be profitable, greater than 0 profit. Okay. And I need only top 3 meeting all this criteria. So this and this and this and this, all of them work together. And we got these 3 members meeting all of these conditions set up. Okay, I hope it's clear. So dimension filters, we have so many different options to filter the data based on dimensions. General, where it's a simple selection criteria. Wildcard, where you give the match value and look for what you want from it. Condition tab to set up any type of conditions based on any field. And top to put a limit on the number of data points. Okay, so this was about dimension filters. Similarly, we can also put filters on measures. Measure filters. So when we talk about measure filters, we have certain options like range of values, at least option, at most option, and we have a special option. We will see these now. Okay. I will recreate the same chart across different subcategories. I'm looking at the profit. Okay. Now, I would like to filter the data over here based on the profit. Okay, based on the profit. So I'm going to take profit into the filters shelf. So when I take profit into the filters shelf, you look at this. Whenever you take a measure into the filters shelf, Tableau gives a pop-up. It's asking us, how do you want to filter on this field profit? I would like to filter based on the sum of profit, because that's what we are looking at in the graph, right? We're looking at the sum of profit. It will make more sense to filter it based on the sum of profit. And when I click on next, it is going to show me the complete range of values that I'm dealing with. So the least profit is a loss of 17,725, which is coming from tables. And the highest value, highest profit per subcategory. You see, Tableau is intelligently identifying what are the members on the chart, and accordingly it has populated the range. Highest profit is a profit of 55,000 coming from copiers. This is the complete range. Now I can use this slider and fix the range. Let's say I want those members whose profit is in this range. Let's say using the slider, you're not able to precisely set a value. You can definitely type it in. I want those members whose profit is in the range of 5,000 to, let's say, 30,000. If I apply, you can see the members. You can see none of these members have a profit of less than 5,000. Everything more than 5,000. And nothing is going beyond 30,000. I mean, not even beyond 27 here. Maybe the next value is pretty high. Okay. The other option we have is at least. At least is where we mention the minimum value, and the highest value comes from the chart, the way you create the chart. So I want those members which are making a profit of at least 20,000. Whatever could be the higher end. I don't know about that. Minimum 20,000. Very, very interesting feature and helpful feature. Let's say you have to identify, in this case, subcategories, making a profit of at least 20,000. Meaning what? 20,000 and above that. Then when we do this, it's done. Let's say the at most option, you might have guessed by now, right? It's the opposite of at least. So under at least, if I was able to specify the minimum value, here I will be giving the maximum or the highest. I need the list of subcategories making a profit of at most 20,000. Means maximum 20. I'm not interested in products which are going beyond 20,000. Up to 20, up to that value. So it's going to give me the rest of the members. You see? All right. So range is where you get to specify both the begin and the end. At least is where you get to specify the minimum value. At most is where you get to specify the higher end value, maximum. We'll talk about special. Now, whatever, I'm putting range of values here, right? I'm going to take range of values and I'll not change the range. I'll just click on OK. Whether it is a dimension or a measure or a date, you can make the filter an interactive filter by simply showing the filter. So when I go to that profit pill and select the option to show the filter, the complete range of values will appear on the right side, as you can see here. Okay, this is the range of values I'm working with. Now, end users also will be able to see this. They will be able to see this and they will be able to interact with the chart through that filter. They will be able to set the range and even slide it like that. Okay, so you're making the graph interactive, not just putting a filter. You're giving the ability to your end users to work with that filter and get the desired output. Let's talk about the special option that we have under measure filters. I will use a different data source here. A very tiny data source that I created simply to explain this concept. Okay. What's the name? I think this one. Yeah. Okay. So let's see. Here I have a list of departments and we can see the profit from each department. Department A is into loss, a loss of $100, let's say. B is giving us profit. E is a no profit, no loss situation, 0. And F is profitable. But C and D, you can notice, are nulls. Null meaning nothing has been entered in that column for them. Okay. It's not profit. It's not loss. It is not 0. It is just nothing. It's left blank. Let's assume that these two departments do not deal with money at all. They don't deal in monetary transactions. Therefore, there is no profit entry at all. Now, I need to create a report showing the list of departments and their profits. However, I'm asked to display only those departments with not null values. Meaning, those departments which have an entry in the profit column. I should not display nulls. How do I specifically target nulls and remove that from the chart? Okay, so I will take profit into the filters shelf. Based on the sum of profit, I'm going to filter the data. And here the special option comes in handy. Very, very useful feature. Right now it is showing all the values. Nulls, non-nulls combined. If I say I want only non-null, let's apply and see. You see? C and D got eliminated. They got filtered out because they were holding null profit. Now, if I have to create a report with the list of departments which are not dealing with money and thereby they don't have an entry in the profit column, in that case, I'll have to choose null values. It will give me the other two. If I go with all, I will get everything. Okay, here I'll go with non-null. I'm not interested in nulls. So I'm going to remove nulls by selecting the non-null values as my option. Job done. Okay, it's that easy to deal with nulls. All right, so that was about measure filters. Let's now talk about date filters. How do we put a filter on date? We have a lot of options here. Okay, so let's see that. I'll go back to sample superstore. Here's a report where I'll be looking at the profit from different years, and I've drilled down to quarter level. This is a discrete report. However, we have year and then we have included quarter. So under each year, data for various quarters is coming up. I'll also turn on the mark labels. Now I would like to filter this data using the date pill, right? So I'll have to take the date field into the filters shelf. Now this also gives us a pop-up. It's basically asking us, how do you want to filter on the date field? Do you want to filter based on years, quarters, months, days, combination of month and year, month, day and year? We have a lot of options. I would like to filter by year, suppose. Next, it's showing me the list of years. I'll just click on OK. I'm not doing anything here. I'm going to make it an interactive filter. Then from here, the end users can select whatever years they might be interested in. So you're making it an interactive filter. This is like a discrete filter. Select what you want and deselect what is not required. Like that, we can have multiple filters. Okay, we can have multiple fields in the filter shelf. We can have multiple occurrences of dates, each at a different level. Suppose I would like to filter by quarter. So these are the list of quarters, which I'm going to show. Here are the quarters. Now I can choose whichever quarters data I might want to see. All right, pretty simple and straightforward. But we have other options. I'm going to clear the filter. How do you clear the filter? You can simply drag the pill out or click on the drop-down icon of that pill and select the option to clear the filter. Either way, it will do the same. Now I'm going to take that into the filters shelf and I will filter based on the range of dates. Range of dates will give us the complete range of dates that we are dealing with. So in this version of Superstore that I'm using, I have data from 3rd Jan 2014 up to 30th December 2017. Okay, and now by using the slider, I can pick up any date of my choice. Both begin and end can be modified. Let's say some person took over the company on 1st April 2014, and that person stepped down on 31st July 2016. I would like to know about the performance of the business during this tenure. Okay, in this time period, what was the performance like? What were the profits like? So if I apply, you can notice like this. It dipped down a lot before the person left, right? That way. So range is where you can specify both the begin and the end values. Then we have an option called as starting date, where you can specify the begin value and the end value comes from the data source, just like the at least option in measure filter. So let's say I want to look at the performance of the business from 1st of March 2016 to till date, whatever is the latest data that we have. So if I apply, you see, from a certain date to whatever could be the highest possible date in the data source. Ending date is the opposite of that. From the beginning, from the day of establishment where we have the first entry made into the data source to whatever date is mentioned over here. Okay, so for this time period, it's going to show me the performance of the business. Look at that. Special is again, whether you want to see null dates or non-null dates or all. Here we don't have any null dates, so everything is non-null. I'll go back to range of dates and I'm going to simply click on OK and show this filter. Users will be able to use this slider and they can adjust the date range, look at the information for that range of dates, and also move the slider around. Very interesting option. Okay. And if the end users are not able to precisely select a date, they can click on the date and they will get the calendar picker, from where they can pick up a date of their choice and look at the data. All right. So this is how you can filter based on the date fields. So I hope you all understood date filters. And we also saw that we can create interactive filters. Okay, let's just proceed. Next is context filters. Okay, this is also very special, very interesting, and very useful. But I think I'll show you an example related to context filter on a dashboard. That would be better and easier to understand. Okay, so we'll talk about context filters in the next video, where we will also talk about dashboards. All right. So what we learned in this video is we understood about dimension filters, measure filters, and date filters. And I'll cover context filters in the next video. Thank you so much. I hope it was informative and I hope you're learning something new with every video that you watch. And most importantly, I hope you're all practicing. Okay, if you haven't started practicing yet, then please do start it right away. Please do start practicing. Thank you. Hi friends, in this video, we will be talking about dashboards. In the previous video, we talked about filters, dimension filters, measure filters, and date filters. So the agenda for this module is to understand how to build a dashboard and how to build a story. And of course, we will try to understand about context filters as well. So let's talk about building a dashboard. Dashboard is basically a collection of different graphs that we create. We've seen that in Tableau, we can create only one chart per sheet. Okay, let's say you've created a pie chart in one graph or in one sheet. You can't put a line chart or a text table right next to it. You will have to do it in a new sheet. So when we create different graphs in different sheets, how do we put them together? That is where dashboard comes into play. Dashboard is a combination or a collection of worksheets where the worksheets will interact with each other. So if each worksheet is considered to be a building block, then dashboard is a place where we are going to put them together, assemble them together, and create a meaningful structure. Okay, so how do we create a dashboard? From where do we see the option for creating a dashboard? You can go to the menu bar. Okay, dashboard menu, and from there you can click on the new dashboard icon. Or at the bottom of the workbook, next to the new worksheet icon, okay, there is the icon for creating a new dashboard. This one is the icon for creating a new dashboard. Either way, it is fine. Tableau will open up the interface for creating a dashboard. Then, this is what the left side pane, the dashboard pane looks like on the left side of the canvas, the dashboard pane. It will show you a list of all the worksheets present in the workbook. And it will help us get a preview of the data on different devices. Using device preview, we can do that. We can adjust the size of the dashboard using the size option. We can see the list of sheets in the workbook. Apart from just adding the worksheets, we can add other things called as objects. All right. So let's go ahead and create a dashboard. For that, we need a few worksheets. So I'll first create some worksheets. Let's say I would like to look at the profit of Superstore by state. So how do we do this? A quick recap or summary of whatever we have learned in all the previous videos. Okay, I will take country to detail, and I will take state also to detail once this is done. You can see we have data for a lot of states. Let me put country on the filters shelf, and I will focus only on United States. I don't want data for Canada. Okay, so this is United States data. Now, I'd like to look at the profit. So I'll take profit into the color shelf. Job done. Let's say I want to adjust the colors. How do we change the colors? We double click on the color legend, and then we can choose from the palette. I'm using red and green diverging. Profitable states in green, loss-making states are coming up in shades of red. Now I need a chart showing the top 5 customers by profit. Meaning what? I need top 5 profitable customers. So here are the list of customers, and here's the profit. I will also sort the data in descending order, and we don't need all of them, right? We need top 5 customers. So how to do it? Pause the video here and try it out from your side. Okay, I'll continue. So we'll have to take the dimension customer name into the filters shelf, then go to the top tab and ask for top 5 members based on their profit, sum of profit. Once I apply this condition, you see these are the top 5 profitable members. Now I will simply right click on this sheet name and duplicate it. And here I want bottom 5 customers based on their profit. Because it's the same chart, instead of top 5, I'm saying I'm interested in the bottom 5. So I'll have to edit the filter and change this condition here. From top, I'm going to change it to bottom. Okay. If any of you is trying to do it along with me, please do pause the video and prepare all the 3 graphs. One is profit by state. One is top 5 profitable customers. The other is bottom 5 who are giving us a loss. So what we can do here is, let us say we want to change the orientation of the bars. We want them to start here and move like this. We can right click on the axis, edit the axis, and reverse the scale. Reverse the scale from 0. This is negative now. All right. This is not mandatory. I'm just doing it to show you. Now, how do we create a dashboard? We need to click on the icon for creating a new dashboard. This here. Or you could go to the menu bar and do it. I'm going to click on the icon. Here's the interface for creating a dashboard. I can see the list of all the sheets present in the dashboard pane. And to start building a dashboard, we just have to drag them and drop them here. I'll drag the profit by state map first. It's simple drag and drop, okay? And I'll put the top 5 customers below the map. I'm going to take the bottom 5 customers next to the top 5. Look at the gray area as I hover the mouse pointer. So where exactly do you want to put it? You need to accordingly go and place it there. Okay. Now you can notice that we have very little data, right? Just 5 members, top 5 and 5 bottom 5. So much space is not required for them. So I will click in the map, go to the border, increase the space given to the map. This looks good. Then at individual graph level, we can adjust the size. There are 5 members and we see there is some unused space left out. So I'll go to the fit option and make it entire view. Similarly for bottom 5, I clicked in the graph to select it. Now I will go to the fit option standard and make it entire view. All right, they have just spread out and utilized the space. If you look at the overall size of the dashboard, little unused space is left out. So to adjust the overall size of the entire dashboard, the best option would be to go with automatic. Under size, click on the drop down icon. You'll get a small menu. Again, click on the drop down and choose automatic. Perfect. Now so we have a dashboard where we have put multiple worksheets together. Now my requirement is this. When user selects any state on the map, the remaining graphs should get updated, showing the data for that state. Okay, right now this is a map and these are the overall top 5 customers. And these are the overall bottom 5 customers. Okay, but what I want is when I select a state, data for that state, top 5 from that state should appear and bottom 5 from that state should appear. I hope you all understood the requirement. How to do it? How do we make this chart itself a filter? How do I make each and every mark or data point here a filter condition? By putting an action. It is called filter action. How do we put a filter action on a graph? Is you select the graph, you will be able to see that gray border kind of thing, right, around the graph. And you can see some controls over here. From here, if I click on this funnel icon, if I turn on the funnel icon by clicking on it, this graph will start acting like a filter. The action will get applied. Okay, let me demonstrate and show it to you. All I need to do is click on the funnel and this chart is now a filter. The graph itself, meaning every data point here is a filter condition. All right. So who are the top 5? Tamara Chen, Raymond, Sanjeet Chen, Hunter Lopez, and Adrian Barton. Now I'll go ahead and select California. Look at what has happened. What is it doing right now? Let's try to understand what's happening right now. Tableau is filtering the data and focusing on California, right? So out of the top 5 customers, whoever belongs to California, whoever has done any transaction in California, that is what we are seeing. Out of the top 5, Sanjeet Chan and Raymond have performed transactions in this state. And you can see the value, profit coming from each person in that state. Okay, out of the total bottom 5 customers that we had, these 3 people have made some transactions in California. But in California, they are giving us a profit. Look at Henry Goldwyn. Look at Cindy Stewart. Look at Luke Foster. They're giving us profits. All right. Suppose I go and select Texas. So what's going to happen? Out of the top 5, these 3 people have performed transactions in Texas, and even the most profitable customer, Tamara Chand, is giving a loss there. He's contributing to a loss. No wonder Texas is into losses, isn't it? And we can notice that out of the bottom 5, the overall bottom 5 that we had, 2 people have done transactions in Texas, and this is the loss that they're contributing to. I hope you're all able to understand what's going on now. Now, when I don't select any particular state, when I click in the blank space, the selection is cleared. Let's try Utah. None of the bottom 5 customers are from that state. One of the top 5 is from there, Sanjeet Chan. Okay, let me try Montana. None of the top 5 and none of the bottom 5 customers have performed any transactions in Montana. They haven't performed any transactions at all. So nobody from the top 5 list and nobody from the bottom 5 list are from that state. Okay, hope you all understood what is going on right now. This is filter action. This is filter action. And the filter action that I applied on this graph by clicking on this funnel is impacting these 2 other graphs in the dashboard. So an entry will be made in the corresponding sheets. You see, action on the country field. Country, region, state, province, map. Action was applied, a filter action. So if you apply the filter action, an entry will be made here. But that was not our requirement, right? What did I say was my requirement? It's this. When the user selects any state, we must show the top 5 members from that state. What is happening right now? It has fetched the top 5. It already fetched the top 5 and it's checking whether these people have any record in California. If they have, it's displaying them. If they don't, it's eliminating them. I need to change this sequence. I need to tell Tableau to focus on the state that is selected first. Give priority to the state filter, the state that is selected in the map. Means give priority to that action. And when user selects a state, for example, California, then Tableau is supposed to fetch the data for that state and store it in a temporary table. Imagine it like that, okay? It is going to apply this action first, bring the data for that state and store it in a temporary internal cache memory, let's say. Then the top 5 customer filter should work with this data. Top 5 customer filter should work with the data that has been fetched and set to context. So obviously, because it's working with only the data from California now, it will fetch the top 5 from that state, isn't it? Now, let's say user selects Ohio. User selects Ohio. Then Tableau has to fetch all the transactions from the state of Ohio and store it in a temporary storage. The top 5 filter should work with this data. And if it's going to get applied on this data fetched for a particular state, it will give us the top 5 members from that state. How do we do this? I hope the requirement is clear, but how do we achieve it? How do we make sure that Tableau gives more importance? It gives precedence to the action filter. How do we make sure it applies the action first? And then on the data that has been fetched for that state, it applies the remaining filters. That is where context filter comes into picture. Okay, so I'll go to this sheet and I will set this filter to context. This is what I need to give more importance to this filter, right? So how do you give importance? Simply go to that pill in the filters shelf and add it to context. Context filters will appear in a gray colored pill and they are applied before any other filters in the sheet. They are the first filters to be applied in the sheet. First context filter will be applied and on the data that has been fetched by the context filter, remaining filters will work. So I'm doing it only on the top 5 sheet. I'm not doing it in the bottom 5 sheet. Let's see. Now if I choose California, you notice how Tableau has refreshed the top 5 list. Why? Because now it is fetching the top 5 members from that state. What about bottom 5? This has not been set to context. So it fetched the overall bottom 5. Out of those 5 members, 3 of them belong here. Okay, let me clear the selection. And now I will apply the action filter to context even on the bottom 5 list. Okay, this is context, which means this will take more precedence now. So if I select a state, look at the refresh list. Top 5 from California. Bottom 5 from California. Let's select Illinois. Top 5 from Illinois. Bottom 5 from Illinois. Let's select Ohio. Top 5 and bottom 5 from that state. Montana. Top 5 and bottom 5 from that state. Okay. So upon clearing the selection, meaning when we don't choose any particular state, we're looking at the entire data. This is the overall top 5 and bottom 5 list. All right, so I hope you all understood context filters. I didn't do it in the previous video. I said I'll cover it here, right? So I hope it's clear. So when you set a filter to context, it will be applied before any other filter. That's it. You're just giving it more priority. Okay. So we understood how to build a dashboard and we also understood about context filters. Let's now quickly understand about how to create a story. Story is called as guided analytics or a narrated walkthrough. It is basically where we arrange all the worksheets as well as the dashboards that we have created in a particular sequence to convey our story, to convey the information. Okay. For instance, imagine that you are managing a team and you have to give a presentation to a client. So you asked your team members to prepare some slides for that presentation. All of them have taken one topic each and they've prepared the slides and they send it to you. Now you will not present the slides in the same random sequence in which you have received them, right? You're going to first arrange all of those slides in a proper logical sequence, and then only you would present it to the client. So maybe the welcome slide first, the agenda, topic 1, topic 2, and then the thank you slide. So you will arrange it in a logical sequence. That is exactly what we do in a story. We're going to arrange the worksheets and dashboards in a proper logical sequence. So let's see how to create a story by clicking on the new story icon, which is there next to new dashboard. We can adjust the size of the story by going to the bottom left corner and making it automatic. The story will resize to fit any screen on which it is displayed. We can see list of all the worksheets and dashboards. So just drag and drop. Okay, first point is here and every point has a caption box. So we can just go to the caption box and we can write some information. Let's say profit map showing the profit for all the states in the US. Of course, we have data only for 49 states here. We don't have data for Alaska, but let's say all states, no problem. Now I need to bring the second point. So if I drag it here, it is going to replace the existing point. I don't want to replace the existing point. I need to add it as another point. So what to do? We have to drag it here towards the caption box. If I leave it here, it will become the first point in the story. And if I leave it here, it becomes the second point. I'll leave it here. So this is top 5 customers. For every point in the story, you can narrate your story. You can explain the information in that story by writing the information in the caption box. Now I'll bring in bottom 5. I want to place it here towards the end. Bottom 5 customers. And finally, the dashboard itself. I'll bring it and place it here. So this is my dashboard. Getting it? So story is a place where we arrange all the worksheets and the dashboard in a particular sequence. Now, let's talk about updating a point. Okay, I'm going to put one interactive filter on region. Let me show the filter on region. Okay, we have data for Central, East, South, and West. Okay, I'm showing a filter on region. Let me go back to the story and you can see how it automatically appeared. I have an interactive filter on region. I would like to focus only on, let's say, West. So I will deselect everything else. So here my map is showing me the profits from West region. I would like to save this as a new point. Let's say my client will not have the time to focus more on each and every individual region. I need to create ready-made reports ready for analysis. So specific to West region, I need to save this as another point in the story. How do we do that? How do I save this as another point in the story? So I made modification to the map corresponding to this particular caption box, right? So on this caption box, you can see certain icons. This is to remove that point, delete it. This is to revert the changes. It just goes back to the original. Okay, I'll keep it focused on West. This is to update the point. So the existing point will be updated and it'll show me data only for West. I don't want that. I want to save it as a new point. So when I click here, it will get saved as a new point. Getting it? So we still have a map showing us the data for all the regions. And I am now focusing on West. That's another point. Let's say now I want to show the performance of Central region. And I would like to point out that Texas is giving a really bad loss. How will I do it? First, I'll have to save it as another point. How do we save it as a new point? We go to the caption box, click on the save as new icon. Okay, now that will open another caption box for me and I will write about it. This is the profit from Central region. Please note that Texas is into losses. So whatever is your analysis, whatever you find, you can present it to your client through a ready-made report like this. That is a story where we arrange the worksheets and dashboards in a sequence. And also we can create multiple points in the story by changing the state of the graph using interactive filters or parameters or actions, whatever it is that you might be doing. Okay, I hope you'll understood about story. And of course, context filters that we covered. So that's about how do we build a story. We discussed about how to build a dashboard and we discussed about how to build a story and we discussed about context filters. Okay, I hope the video was informative and thank you all so much for your support. Please do continue giving us your support and I will see you in the next video. Thank you. Hi friends, welcome back. So this is the last video in the series of videos that we have done on data visualization using Tableau. So thank you for your support throughout and please do continue your support like this. Really appreciate it. So now in this last video, we are going to look at how to publish the workbooks that we have created to the Tableau public gallery in order to save our work. So when we create any workbook using the Tableau public tool, the only place where we get to save it is the public gallery itself. All right. So what are the steps to save the workbook? I'm using Tableau public itself. Okay. So how do I save it? I have some charts which are created. I have a dashboard, etc. And I would like to save it. So the method or the procedure is we go to the file option on the menu. Okay. And from here, there is an option called as Save to Tableau Public As. When you select that option, you will get a pop-up window where we are supposed to sign in to our account. Okay, now if you have an account with the public gallery, you can use it. And if you do not have an account, then you'll have to create an account by going to this option here, create one now for free. You will get a small form that needs to be filled in with your first name, last name, your email, and a few other things. Okay. You can give your personal email ID. It need not be a business email. You can give your personal email ID and create an account for yourself. So once you have created an account, you can now sign into your account. After signing into the account, we will be prompted to give a name to the workbook. Let me sign in first. Okay, I'm going to sign in. And I will be prompted to give a name to the account. Okay, there's some problem with the sign in. Okay, so I'm going to give it some name. I'll just call it sample workbook. Okay, I'm calling it sample workbook. And once I click on the save button, this workbook will be published to the Tableau public gallery server, which is an open platform where everybody can visit your profile and see what you have created. So never ever put confidential data over there. in a corporate environment, when you're working on real-time projects, even by mistake, you should not be saving your work on the public gallery. Here, because it is a training environment and we've been using the Tableau public tool, it's fine. Okay, generic things like this, you can put on the public gallery and refer back to it. So once we do this, it is going to get published on the public gallery. And then what? What happens is once it goes to the public gallery, you will be able to find the workbooks under your profile. Okay, you will be able to find the workbooks which are published to the gallery under your profile. So this is one such workbook which I had published to the gallery. Now you may get an impression or a feeling that only one sheet got published. That is not true. All the worksheets that you create will be published and saved. How do we see all of them? Okay, for that, we need to change a small setting. I think I'll have to sign in again. We'll have to change a small setting. Okay, here is the settings button. After you have published a workbook, it will take you to your profile under which the workbook is published and it will show you the workbook. Here there's a settings button, click there and you need to turn on the second option. Show Viz Sheets as tabs. When this option is turned on, we will be able to see list of each of all the sheets. Basically, you can see each and every worksheet listed out along with dashboard stories. So whatever is present in that workbook will get published. And later on, if you want, you can even download that workbook. So we've created a workbook on the Tableau public tool, and then we published it to the gallery. After publishing it to the gallery, let's say I want to download it for reference. So I'll have to simply click on the download icon and download it. Now we have many formats. You can download it as a Tableau workbook compatible with the current version itself. Okay, once you download it, it will be downloaded onto your machine, right? And then you can open it and you can interact with it. It's that simple. So that is how you publish your work to the Tableau public gallery and save it for future reference. All right. So I hope you'll understood how to publish the workbook to the gallery and save it. Now, because this is the last video, I thought I will let you know about the overall program that we have at 360DigiTMG for Tableau. Okay, the overall program is for 30 hours duration. What do we cover under these 30 hours? In these 30 hours, I shall tell you. Apart from the 30 hours instructor-led live training that you will go through, there's a lot of other self-study content that will be provided, which you can do at your own pace. Okay, so we have something called as Tableau Online, right? I told you about the products in the Tableau product suite. We talked about Tableau Online. So you will be taught about Tableau Online. You will be taught about how to use Tableau Prep. Okay. And a lot of other things. Okay, these are two other tools that you will learn in the program. The 30-hour instructor-led program is where you will learn about how to work with Tableau Desktop. Tableau Desktop. In this crash course, we've used Tableau Public throughout, right? So we will, you will learn how to work with Tableau Desktop end-to-end in the 30 hours program. Apart from that, you will get training videos, which will help you understand about Tableau Online, which will help you work with Tableau Online, learn about it. You will get videos which will help you work with Tableau Prep Builder. Apart from these videos, there is a lot of additional material that is available in the form of videos, in the form of interview questions, quiz questions, assignments, case studies, projects, a lot of support and a lot of practice activities are there. So let me just take you through the overall agenda. What is it that we cover? We start from the very basics. Okay, we start off with what is data visualization, why is it required? We look at charts creation. We look at the concept of filters, groups, sets, calculations, LOD expressions, maps, dashboards, and stories. So module 1, Introduction to Data Visualization. Here you will explore all of these things. Okay, all of these things. Define data visualization, understand how to install Tableau desktop, explore the start page, data source page in much more depth, understand about show me panel, etc. Module number 2 is where we focus on what all options do we have to save our work created on Tableau desktop in different formats. We will understand about Tableau architecture, and we will also try to understand about the limitations of Tableau Public. Okay, because Public is a free tool and not all features are available on it. Most of them are, but some of them are not. So what are those limitations? That also will be covered in detail. Then module number 3 is basic charts in Tableau, most of which we have covered. I think all of them we have covered in our crash course as well. Okay, so we will be looking at these things. Module number 4 is where we focus on sorting, and we'll get into a much more detailed understanding of filters, groups, creating set, combined set, hierarchy, and highlighter. Then we proceed to module 5, where we deal completely with data connections in Tableau. How to join the data coming from multiple tables in a single database. How to combine data coming from completely different data sources. Multiple database joins, also referred to as cross-database connectivity. How to perform unions. Writing custom SQL queries to fetch only the data that is required for the analysis. A very, very important concept called as data blending, data extraction. So this module completely focuses on data connections, okay? And data interpreter, of course. Data interpreter is a feature that will help Tableau to understand the data better, like the headers, subheadings, column names, footnotes. Such things are understood better with this. Then we proceed to the next module, Visual Analytics, where we will look at a few more charts. Slightly more advanced compared to what we have covered in module number 3. So dual axis, blended axis, heat maps, tree maps, Gantt charts, bullet graphs, reference lines, bands, and distribution concept. Then we proceed to the next module, which is on advanced analytical capabilities of Tableau. Tableau is primarily a data visualization tool, but it can do a lot of things on the analytical front as well. We can do prediction with trend lines. We can do forecasting. We can do clustering, distribution analysis by creating histograms and box plots, which are used for outlier detection. So these are the advanced analytical capabilities. And here we will focus on parameters as well. We'll also look at parameter actions. Okay, parameters are dynamic values which replace constant values, and it's a very, very important concept. So we will do a lot of examples to understand about parameters, their application, and their usage. Then we proceed to maps, geographical maps. Introduction to maps, understanding the roles, creating different types of maps like filled map, symbol map, combination map, density map, using pi as a mark type, exploring map layers and data layers, and editing unrecognized locations. See, there are many places that Tableau can plot, but there are also places which Tableau doesn't recognize. So if it is unable to recognize a location, how do we make it recognize it? And how do we make it plot it on the map? We can do it using two options, editing unrecognized locations or by a concept called as custom geocoding. We will talk about custom territories. We'll talk about how to create polygon maps, work with spatial files, WMS servers, Mapbox tool, background maps, and map search. So it's quite extensive here. Then we proceed to the next module where we cover dashboards and stories in detail. We talk about device designers, sizing options, actions, objects, and building stories. Then we proceed to calculations. Because pretty often you will come across scenarios where you have all the data, but it may not be in the format you want it to be. It may not be sufficient. You may have to manipulate it. You may have to write formulae to work with numerical data, to work with text information, to work with dates, write logical functions. So we will cover everything about calculated fields in this module, including an in-depth understanding of all the quick table calculations, each and every one of it. Then we proceed to a module called as level of detail expressions, LOD. This by far is the most difficult concept when it comes to calculations in Tableau. But we have a complete module dedicated to LOD expressions, where we will understand what are those expressions like fixed LOD, include LOD, and exclude. And we will see some real-time use cases on the application of these LODs. It doesn't stop with 3 use cases. There are many more use cases to which you will be given access. You can watch the videos and practice them. And if there are any doubts at any point of time, I'm available 24/7. Okay. Then we talk about custom charts. See, we saw the Show Me panel, right? And I said that there are 24 charts that we can create from the Show Me panel. It does not mean that we can create only 24 charts. We can create hundreds of charts in Tableau beyond the Show Me panel, okay? Beyond what is there in the Show Me panel. So here we will be looking at a few custom charts, which will give us an understanding of how to manipulate the data and create a variety of charts, even though they might not be present on the Show Me panel. And again, the list doesn't end here with 5 charts. You will be given access to a lot of other charts, lot of other videos where in detail explanation is provided for many other charts and how to create them, when to create them, why to create them, all this. Okay. So this is the overall agenda of the complete program that we have for Tableau at 360DigiTMG. So I request you, you can even go to our website and you can check out the Tableau course over there. We also have a full stack program on data analytics, where apart from Tableau, you will be taught how to work with Power BI. You will be taught advanced Excel, SQL, okay, and data visualization with Python. So it's there. So please do visit the website and you get an understanding about the data analytics course and many other courses which are offered. And you can get complete syllabus regarding Tableau as well. Okay, friends, thank you all so much. Thank you for your support. I hope you enjoyed all the videos in this series. If you have any doubts at any point of time, please do reach out to our team and we are happy to help. All the best to all of you. Thank you so much. Bye-bye.